physics students. Research in physics education has evidence that these students have difficulties to transfer their mathematical knowledge to the physics course. And mathematics can never be considered just as a prerequisite that you can use in physics once you know it. There are epistemological differences, and also with a social cultural perspective, differences in the disciplinary cultures between mathematics and physics. A recent work by Mathilde Itier and Alejandro González Martin has evidence that there exist inconsistencies between mathematics in the mathematics courses and the same mathematics in the physics courses. The work was about the derivative in a kinematics context in mathematics. Aude Cosario started to establish a classification of the possible differences, and she distinguished between differences in the notations, in the objects manipulated, and in the techniques used in math and in physics. In our work, we choose a particular perspective. Following Florenza and colleagues, we consider that in first year physics studies, the mathematics and the physics course are two different institutions. So we speak about transition, but it's not the secondary tertiary transition. Naturally, these students are first year students, though they are also experiencing the secondary tertiary transition. But the transition we consider here is not a transition happening in time. It's a permanent transition between these two institutions, the mathematics in the mathematics courses, the mathematics in the physics courses. In what follows, and for the sake of brevity, we will just call it the math-physics transition. Choosing this perspective lead us to consider that it is a complex phenomenon with multiple aspects. And as researcher, we can study it with particular theoretical perspective. Each perspective will act as a lens, evidencing some aspects and hiding others. Our choice in this study is to refer to the anthropological theory of the didactics as a first lens to compare the mathematics of the mathematics courses and of the physics courses. And we also refer to the didactic contract as an overarching theoretical frame. So just a quick word on the anthropological theory of the didactic. It is an institutional perspective, and we use in particular the concept of praxeology. A praxeology comprises 4 elements: a type of task, gathering task with a similar aim, a technique to accomplish it, a technology, which is a discourse explaining and justifying the technique, and a theory, which is a more general discourse explaining and justifying the technology. While the didactic contract, coming from the theory of didactic situation, is a set of rules, mostly implicit, which each partner in the didactical situation, well, this means naturally the teacher and the students, believes to have been imposed in them. So the research question we will study in this presentation are as follows. Which differences appear between the mathematical praxeologies used in physics course and those used in mathematics courses for first year physics students? And what do we learn from these differences in terms of didactic contract? And the second question is more linked with curriculum design. Which resources can support the students in the math-physics transition? The methods we will use in this study, we start with a praxeological analysis. We will focus for this analysis on the mathematical themes of derivation, integration, and differential equations. So we start by praxeological analysis of exercises in a mathematics textbook for first year physics students. we establish a first list. Then we also identify praxeologies in physics textbook for the same students. We only keep in the list the praxeologies containing mathematics in one of their 4 elements. Our reference for the mathematics is the official curriculum, first-year curriculum for these students. Then we compare the 2 lists, observe similarities and differences. One important choice is that we characterize a type of task by a verb and a complement, like determine the position. And it's important to say what is the same and what is different. And finally, coming from this list of differences, we infer a disciplinary didactic contract rules. Because some of the praxeological differences can come from different contract rules. And Pauline will develop an example and present our results.
All right. Thank you, Ghislaine, for the presentation of our background and methods. Now I'll illustrate it through an example and present our results also through the lens of that example. So what would praxeological analysis look like for a given exercise? Well, let's take a look at a chosen exercise first. We're studying rectilinear motion, so this was taken in a first-year physics textbook that was in French. This is my translation of the exercise. We're told to analyze an object which is moving it along a straight line and has an acceleration given by minus omega squared times x. And we need to find the expressions of x of t and v of t, which of course are the position and velocity given certain initial conditions. I've divided up the corrections into 2 parts, which will make sense later, more sense later on. The first part of the solution is to actually find that this equation is actually a differential equation and rewrite it in a way that it's that makes it more obvious that it is a differential equation. I'd like to bring your attention to the fact that already in this part of the exercise, several different notations for the derivative are used. And the second part of the correction is solving of this equation. Equation here is different to what we would usually find in mathematics. However, it is very common in physics. The following part of the solution is just calculating x0 and phi using the initial conditions. So what's a praxeological analysis of this exercise? Well, everything stems from the actual task that the students need to solve. The task is to find the expression of x of t and v of t. We've grouped it into the type of task, determine the position and velocity, and those are together because the position and velocity are calculated together within the correction and not separately. The technique used to solve this type of task is actually composed of 2 different types of tasks. The first one is to recognize that the given equation is a differential equation, then you need to solve it. And these 2 types of tasks can then themselves be analyzed using praxeologies. The blue types of task has a technique that is quite interesting because it actually blends physical elements, as in the definition of the acceleration, and math differential equation, and you need the concept of differential equation in order to recognize it as such. The technology reflects that in blending mathematics and physics, and therefore the theory does as well. Now, the orange type of task is a very common type of task, both in mathematics and in physics first-year textbook. However, it's slightly different. We're aware that this general solution can also be found in mathematics. However, it wasn't in the mathematics textbook that we personally analyzed, and is way more common in physics than in mathematics. So this was our example, and we're going to use it to illustrate our more general results, both in terms of praxeologies and in terms of didactic contract rules. So first, in terms of praxeology, we find that some types of tasks appear in both physics and mathematics. Technologies are usually very different in mathematics and in physics. Moreover, we tend to find a larger variety of techniques in physics associated to one given type of task. And this, of course, is due to the physical context that is added on in physics exercise. In our example, this was the case for solve a differential equation. We also found some types of tasks that only appear in physics, and these types of tasks blend both mathematics and physics. What's interesting is that we haven't found 10 tasks that blend mathematics and physics in the mathematics textbook. So mathematics deals with mathematics, physics tends to deal with mathematics and physics. In our example, this was the blue test. And in terms of the rules of the didactic contract, well, if we take a closer look as to why the task solve a differential equation has different techniques used to solve it. Well, we can express that in terms of rules. Is that in mathematics, the algebraic expression of a function tends to be chosen to evidence characteristic values. For example, the general solutions of a second order equation as the one that I've highlighted here makes it very obvious that when x is equal to 0, y of x is equal to a, and therefore, since y needs to be equal to 0 at x equals 0, that a needs to be equal to 0. However, in physics, we don't tend to evidence characteristic values as much as significant physical parameters. So the equation here, x of t is equal to x0 cosine of omega t plus phi, makes it obvious that this is a sinusoidal wave, that it has a certain amplitude and a certain phase. And it makes it more obvious which physical parameters have value in physics. So in math and in physics, we want to be efficient. However, the efficient criteria in math and in physics tends to be different. So these were our findings. And with that in mind, we tried to analyze pre-existing resources that we haven't created after analyzing these textbooks, but that we analyzed to find how they would be able to support the transition. These resources are Math for Science, which is a project aimed at producing resources for first-year science students by pooling together efforts from researchers, mathematics, and science teachers. This was spearheaded by Aude Kossaire, my other research advisor that couldn't be here today. It produced many different multiple choice quizzes, in fact, over 1,000, along with method presentations that I'm going to analyze now. A typical Math for Science resource looks like that. It takes an example and solves it, perhaps another example and solves it, and then presents a general method for the resolution of this type of exercise. In my case, I'm going to analyze that was called that's interesting. We're given very as very physical limitations for this is an exchange of temperature. And then we're given the resolution and the method. Two things that I'd like to point out in this method. First one is that there's an explicit recognition step, which isn't the exact same one as the one that we've identified in the physics notebook, but still the physical differential equation is explicitly linked with its mathematical representation that is here. And the second very important part of this method is this very explicit identification steps where each mathematics term is linked to physical quantities and parameters. And then each part of the solution is calculated and initial conditions are used to find the constants. So how does such a resource can support the transition? Well, in many different ways. In fact, it can help close the gap between mathematics and physics by bringing physics into the mathematics course. One important thing is that these resources are meant to be used in the mathematics class and not necessarily in the physics class, which means that students work on physical exercises with a more mathematical lens. And it also aims at making the gap between mathematics and physics more explicit. It doesn't erase either the math or the physics from the exercise. It makes the fact that both coexist more explicit. In terms of didactic contract, well, physics notations are used. The equation that is studied is an actual physics equation with a typical initial temperature, exchanger temperature, and terms such as quantity, which is not used in math. In mathematics, you would call y a function, and you would use only t and not t of t to refer to the function. The fact that physical notations and terms used are used in the mathematics class helps close the gap. And also in terms of didactic contract, the gap is more explicit by the fact that both the equation and each of their terms are explicitly linked. Now, in terms of praxeology, we're working on a physical praxeology. The type of task determine the temperature is obviously a physical praxeology, and in terms of making the gap explicit, well, the fact that this recognition step and identification steps are an explicit part of the method, of the technique that's described by the methods, makes the gap more explicit. And the other important part is that mathematical and physical elements are present and blended in the praxeology, which is something that we've noticed in physics only and not in mathematics classes in usual textbook. All right, I'll leave it to Ghislaine to conclude.
My mic. Yeah, only a few words of conclusion. First, we retain from this ongoing work that choosing this perspective that students experience a permanent transition between math in the math course and math in the physics course is a fruitful perspective to analyze students' experience and try to support them in this transition. We had two aims in our work, and we still have. The first was understanding this transition, which means for us analyzing changes in the praxeologies and inferring hypothetical contract rules. So in our future work, we need now to go into the classrooms, make some observation, interviews with students and teachers to confirm or not the existence of these contract rules. But it was important to start with the praxeological analysis to make this hypothesis, because contract rules are implicit. And the second aim is more linked with curriculum design to contribute to support the math physics transition. So we started with the Math for Science resources and analyzed, as we illustrated it here, the potential contribution of these resources. Now we are making some interviews with students using these resources to analyze their experience with them. And later, we have the project to design a teacher education program using some of these resources and the results of our analysis. So thank you very much for your attention. And now we're ready for your question and happy to discuss this with you.
Thank you for your attention.
So Kitty, I don't know how we can organize for the question. I can see that there is a question in the chat.
Sorry, I was talking and you didn't hear me. We can have a couple of comments and questions because we're a little bit behind the schedule. Charles, maybe you can read the question online, and any questions from audience here?
Perhaps I can take the message question already, which was by Howard. So Howard asks, will the same analysis and approach be extended to chemistry, biology, and economics, or which have a foundational relationship to mathematics? Not easy, but it could be. I heard the first 2 months was to math and mathematics and the math and physics, because they don't appear exactly at the same point. So a typical task in physics will like find the velocity, and then the math will appear only as a second step in the technique. On that step in physics, we'll be able to find and to adapt it. Well, me or someone else could adapt it to chemistry, but it's not the subject of my personal PhD right now. And I don't think it has been done in the past. You said maybe you want to add on to that.
And I perfectly agree with what you said. We are working both on this content, math and physics, and on a general method to approach this experience of students. So if the method is fruitful in physics, but we still need to work further, probably we will try to transfer it to other subjects with other colleagues also.
Yeah, one important point is that Aude, which couldn't be here today, is actually a physics education researcher, and Gisèle and I both are mathematics education researchers, and I think that this work would be very hard to do without at least another colleague in chemistry or in economics. So.
Other questions? Testing. Thank you. One more question from Mira.
Okay. Hello. I'm sorry. I would like to question your basic premise. Sorry. You suggest that we teach physics within mathematics. Why not the other way around? For instance, there is a series of books published at Berkeley. So it's Berkeley course in physics, 5 books which they do exactly that. The reason being is that lots of things in mathematics can be stimulated and understood better if you understand physics. For instance, I learned about gradients and divergence and curls in physics course and not in some abstract math course. I think that would make a lot more sense. So can you please comment on it? So why did you decide to teach that in math rather than teaching math in physics context? Thank you.
So this was actually one of findings that there is mathematics that are courses. It might be a very French way of doing things and very related to French institutions, but I think you're very right that mathematics only does mathematics, and physics does mathematics and physics. And I think that was reflected in the fact that there are mathematical and physical praxeologies in the physics course. However, the course at Berkeley, as I've understood your question, is a physics course or a mathematics course? I can't. Is it?
Physics books.
It's a physics books. So that is actually what makes sense. We tend to do math in physics, but not physics in math. And so I completely agree with you. However, I think we don't do enough physics in the mathematics class, and that it could highlight mathematics better. So I don't think we're actually in disagreement here. I don't know if maybe Justin can add on to the conversation. But
No, I think I agree with you, Pauline. I think this choice is more or less constrained by the French curriculum. At least in our university, it would be very complex to do the other way around.
Yeah, the French institutions tend to have a very formal and very structural mathematics classes, and the applied math tends, and we don't really take examples from biology or physics in the mathematics class. That might be a very French way of seeing things.
Okay, thank you, Pauline and Yuzhan, for your talk, and we can
Thank you
continue
very much.
discussion afterwards. Miro might not be satisfied with the answer, so the discussion can continue. Thank you very much.
Yes, for sure. All right.
All right, so our second talk for today good. Okay. So our second talk is brought by Igor Kontrovich from University of Auckland. He's currently in the UK, which makes this talk possible. Otherwise, he will have to get up at 4 o'clock in the morning. So Igor is a senior lecturer at University of Auckland. In his research, Igor's aim is to offer theoretically grounded and empirically based insights to improve student learning experiences. He has worked with math education colleagues from all over the world, including Canada, Israel, Italy, Poland, and the UK. The project's findings have been shared in more than 80 research publications. Igor, are you ready? The floor is yours.
Thank you very much, Kitty. Thank you, Miroslav, for the invitation. Thank you all for being here. Just let me know if the slides are showing.
Great.
Okay, great. So let me take this opportunity to tell you about a project that we started in Auckland, imagining that it will go in a particular direction. Specifically, we were collaborating with colleagues at the University of Edinburgh who developed an automated system for assessment. And we thought that if we will put students in groups, in small groups, and engage them with specifically designed modules for typical undergraduate courses in linear algebra and calculus, so there will be some interesting learning happening in these small groups. But what we did not expect is the power and this tacit role of the interpersonal interactions that were happening in these small groups that we created. And this is where I'm coming from today. So I want to draw your attention to our common talk these days about the power and potential of student-student collaborations. So let me give you just one example from the vision and strategic plan from the University of Auckland that says that students will learn from each other and participate in imaginative and innovative programs designed by leading researchers in their discipline in engaging with their fellow students. You probably remember that in 2016, the Conference Board of Mathematics Science explicitly called to invest time and resources to engage students in active learning, in post-secondary thematics education, and they also add that there are enough evidence at this moment to talk about the benefits of active learning, and we know that people often interpret it as something to do with student-student collaboration, teamwork, and stuff like that. It sounds very good. It sounds very compelling. And research supports this idea indeed. What can make more sense than if we make students process mathematical ideas together, students will deepen their understanding and build communication skills, collaborative skills, appreciation for diverse path to solutions. The talk about collaborative learning that can be called differently, by the way, I'm not insisting on the name in this presentation. It's not new, of course, and it's not specific to the university context, but specifically to the university context, it aligns very well with different movements that this institution appreciates. So, for example, all this talk about student-centered instruction, it works well with that. Some people talk about the importance of engaging students in mathematics in the way that mathematicians do, and it requires quite a bit of interaction and collaboration. And we often hear the idea of preparing students for the job, for the current job market that endorses communication and interactions and teamwork, project-based work, stuff like that. So it really kind of seems like a piece of a puzzle that fits very well. What I would like to suggest and illustrate to you today, that actually collaborative learning, when we put students together and ask them to work together on some sort of mathematics, we generate an arena where issues of cognition, affect, identity, and positioning, they emerge and they intertwine in quite complicated ways. And from the research perspective, we can quite easily find studies that are interested in cognition only or interested in affect only, but there are not too many studies, especially in the undergraduate level, that look at these things together. So we, in our project, we wanted to see how all these dynamics, how they shape each other, how they support each other, or how they get on the way of each other. We decided to work with a cognitive framework, which is looking at different aspects of learning processes, and specifically, it is attentive to students' discourses. It looks at all these issues through the lens of communication and discourse. In particular, cognition acknowledges that when students in the reality of a classroom, let's say, when they participate in a mathematical discourse, the participation is not pure mathematical. There are many additional issues that come to the surface. And the framework distinguishes between something that it calls mathematizing, which is the generation of narratives that have to do with mathematical objects, and subjectifying, which is the generation of narratives about the participants of mathematical objects. So when we, for instance, create a sentence that has to do with mathematical objects only, the derivative of this function is, this is mathematizing. When we work with someone and we say, wow, I like your idea, so this is from the area of subjectifying. And a few years ago, in a similar attempt, Einat Heidmitsuanim from the Technion University, she came up with an attempt to bring together issues of cognition and mathematics with issues of affect and positioning. And she created this preliminary tool that I recreate quite briefly here, that talks about different types of things that could be said and done in a collaborative setting. And she distinguishes between 3 levels. I will not focus on all of them. I will just give you a sense of what she's talking about. So on the first level, she talks about the fact that we can generate mathematical narratives. And this is also an act of positioning. So imagine someone, and I will give you an example in a few slides. Imagine someone that constantly in a collaborative setting creates mathematical narratives. Yes, this is great maybe for progressing the work on a problem, but it also positions this someone in a collaborative setting. It says something about them. The same a similar thing can happen on the second level when people position themselves in relation to other people and their mathematical actions. On the other end of this scale, in the subjectifying column, we can find instances of something that Einat calls implicit identifying. So when someone says, wow, you're so good with mental calculations, this is not just a compliment. This is also a message of a person who says that, some sort of an acknowledgement about themselves. So it often comes from the point of comparison. And on the highest level, and this is what I would like to emphasize and to what I will return today, is the idea of general narratives. These are dominant narratives about mathematics and things that happen in mathematics, that don't happen in mathematics, that are not necessarily present in a specific conversation that happens here and now. But if we look at what people are saying within their collaboration, we can see some sort of similarities or maybe differences with the dominant narratives about mathematics. Hopefully, these things will become a bit clearer once I give a bit more vivid examples. So as I said, this was a larger project on undergraduate small group learning with the software called Stack, which is an automated assessment system that can deal with quite sophisticated questions in different areas of mathematics. We wanted to develop modules, sequences of problems around topics that students study in class, and we wanted to give them an opportunity to revise issues that we know are often problematic for students, and to see how they make sense of the feedback from the system and how they process it together. The way that it works in Stack, the students enter their final answer, or they choose among options, or it could be some visual that they choose. The answer does not necessarily need to be numeric. It could be quite a sophisticated formula that the system is able to process and assess. We recorded the interactions between the students and the screens. These were undergraduates taking typical courses in calculus and linear algebra. Some of them were mathematics majors, some of them were coming from other disciplines. I'm going to show a few excerpts from a collaboration by Sai and Jen, who were taking a very large first-year course, something like 700 students. They did not know each other, so they came voluntarily, and we put them together just because the schedules aligned. It turned out that both of them studied towards a commerce degree with a specialization in finance, and Sai was having A+ achievements in the course so far, when Jan was coming through foundational studies where he got C+, and his course achievement were also in the C range for now. So what we did, we put them, we encouraged them to work together. We presented them with tasks about the dot product in linear algebra, quite, I would say, typical calculation problems. And this is how their interaction begins. So Jans looks at the problem. That it's not very important for the sake of this presentation, so I'm not showing it. Looks at the problem and said, "Oh, I think I know this one." Sai, yeah, we learned that in class. So we see that Sai immediately starts to do the math. So it's 8 times 3 plus minus, and Jan instantly asks, should I write it down? Or Sai, yeah, okay. So I do draw your attention to this beginning because these sort of beginnings are quite telling. So on the one hand, we see that Jan indicates that he kind of knows the problem, but Sai takes the leadership over the mathematizing, and Jan instantly accepts this leadership and even suggests to record it, and the invitation is accepted. Let's continue. Sai looks carefully at what Jan is typing and practically dictates the numbers, dictates the calculation. Jan just repeated to make sure that there is no mistake, and Sai does the calculation. So we see that through the lens of this table that I showed before, we see that on the first level of positioning, on the one that accounts for what actually happens, we see that Sai immediately positions himself as a mathematizer who is competent enough and to do the actual calculations, to deal with the problems, to calculate the final answers, and Stack constantly provides feedback that the answers is correct. Jan quite happily and voluntarily endorses the role of the follower who documents Sai's mathematizing. This is still not enough to propose, of course, that Jan cannot do mathematizing on his own, but it is noteworthy how easily he accepted this role of a follower who documents someone else's math. On the second level of positioning, we see that Sai not just does the math, but he quite carefully dictates what to write to Jan. So he does not leave him much space for even to do very simple and basic calculations. And Jan occasionally compliments Sai's skills and being good with that. So he really expresses his appreciation for the math that Sai leads. And if we look at that from some distance, from this kind of more general narratives about this collaboration, at least at the beginning, everything seems to work. Both students are engaged with the problem. There are many mathematical narratives that are generated quite freely. They collaborate nicely. One is responsible for talking the math. Another one is responsible for writing the math. So it looks very good. And this sort of collaboration continues until there is a twist. And after something like 20-25 minutes, they come across a problem that Sai is a bit hesitant, and he proactively invites Jan to take the lead on this problem, especially that Jan kind of makes these sounds that, hey, we might have seen this in class recently, something like that. So Sai is more than happy to pass the mathematizing ball to Jan. Jan tries it, but very quickly asks Sai to come back and to continue leading their dyad. Sai gives it a go. And he struggles a bit, he sounds uncertain, but he does the math. He plays with the numbers, he gives it a try. But he's so hesitant, and he's really not sure, and he starts ending his sentences with this question mark, and he looks at Jan with a request to validate his math, to tell him if he is true, to check him out, to disagree with him maybe, because he doesn't feel confident that what he does is correct. And he does it once and again and once and again until quite an emotional exchange happens between the two. So Sai does the mathematics and he is deeply engaged in this calculation thing. Jan says, okay, no, because you know, in this kind of irritated voice, Sai continues to play with the numbers. Jan, because the thing is that I have no idea about this lesson. So like, way you talk to me, it feels like you think I know, but I don't, he doesn't. So Sai stops with the math and he kind of, okay, sorry, are you taking this course? Confused. And this is when Jan acknowledges that, yes, he takes this course, but he had other things to do and he missed the whole lecture where the topic of dot products was covered. So he acknowledges that he doesn't have a clue, not just about the problem that Sai asked him to solve, but about the whole sequence in which they were engaged. This happens somewhere after half an hour of collaboration when they are working on problem 6. So this is when the illusion of asymmetrical collaboration is broken. So all the masks have been removed. We realize that Jan was a follower by necessity rather than by choice. And he invested nearly half a session concealing his unknowing. And I link it to this dominant and third level narrative about mathematics as a territory where you are expected to know quickly, on the spot, all the time. And let me recall that Sai's interpretation of Jan saying that he cannot do the math was immediately linked to the issues of belonging. His question was, hey, are you even taking this course? Which again would be linked to this dominant narrative of, in mathematics, if you know, you need to know all the time, here and now. And if you can't do that, we question your belonging. This is a colorful, maybe sad, but a colorful story about learning that did not happen. And the sad part about that is that the ingredients for this learning to happen seem to be in place. The ingredients for this classical ZPD version were there. There was one student who clearly needed guidance. There was another student who didn't have any issue with leading, demathematizing. So they could work together for Jan to complete this lesson that he missed. But it didn't happen. Instead, Jan invested considerable effort in pretending to be a contributing collaborator, and he also did not inquire into Sai's mathematics at all. He really acted as a scribe for as long as he could. And to some extent, Jan was right in being concerned and reluctant about sharing his unknowing, because it turned out once it surfaced, he immediately got the reaction from Sai. So we see quite an alignment that in this complicated collaborative situation, the positioning of both protagonists, according to the theory that we use, it was never there. It was never idiosyncratic. It was corresponding to the dominant narratives that we hear about mathematics. So just maybe a few concluding remarks. I wanted to illustrate the idea of collaborations as a complicated arena where issues of content, identity, and positioning come together, not always in this very successful and Hollywoodian way. There is no reason to presume that our students a priori can navigate the complexities of mathematical collaborations. And when I talk about complexities, I'm not talking about just the mathematical complexities that about which we often talk, but also about the social and interpersonal complexities. And I assign part of this responsibility to these dominant narratives that are in the air, that are quite simplistic and do not acknowledge the difficulty of working together on mathematics and mathematically. So I call for some sort of de-romanticization of student-student collaborations for the sake of research accuracy, because we know that it's not happening in every collaboration, all this beautiful development of learning of everyone from everyone, and for the sake of collaborating students who can lean on these narratives to persevere through collaborations. I suggest that the engagement of students in collaborative learning must be purposeful and carefully considered given the complexity of this setting. And it's also important to me to highlight that the complexity for particular populations of students might be distinctive for a range of reasons, and we should not treat collaborative learning easily. It might be way more complicated for our students than we often assume. Thank you.
Thank you, Igor. Thank you for sharing your work and the twist with us. Any questions from the audience? Any questions online? Do you see? No, okay. There is one.
So from Howard, what orientation instruction were the students given before collaborating?
Yes, I assume that you're asking about the guidelines that we gave them when they actually worked in our lab. We try to create this friendly and atmosphere when we invited students to kind of to get to know each other a bit for a few minutes, and we ask them to work together on the module. And so at some point we even saw in this specific pair that when Jan was complaining about Sai, asking him about his opinion, so Sai was saying kind of, hey, we were asked to work together, so here is my attempt to work with you together, something like that. So.
Okay, the next question is from Colette. What are some practical actions instructors can take to support students belonging in situations like Sai and Jan?
Oh, this is a very good question, and this is definitely too big for me at the moment. I know that there is a lot of research, theoretical and practical, that provides examples, guidelines for situations of this sort. One thing that I can say is that now, when we look at that from the distance of several months, we did not think that we did not take seriously enough this whole struggle that some of our groups will need to handle, and we did not give enough space for creating these social bonds between the students. And maybe if these social bonds were put in place more properly, we would not see situations of this sort. So, for instance, we know that some of our groups were actually friends, and their issues like that were less evident. But again, it doesn't mean that they not existed. It just means that they were kind of less visible.
So the last question online is from Ghislaine. Do you have recommendations for the teachers to support students' collaboration? Might be similar to the previous question.
Yes, I think I addressed that. Thanks, Ghislaine.
Thank you.
Okay, thank you, Igor. I hope you can join the panel discussion that's happening right now, and then we can have a more discussion during the panel. So now I'm going to pass on to Miroslav. He's the moderator of our panel, and he's going to introduce our panelists. We do need a minute to set up some chairs on the stage.
Pam, can you let me know if you can see me on this side?
Yeah, I was just going to do that. If we can actually, we're having a few issues with the moving the camera. We have a static camera at the moment. So if we could move the chairs over to the, this would be the right. So basically directly underneath the screen, as close to the chalkboards as we can get, we our online participants will be able to see much clearer.
Okay, are we all in frame, Pam?
You'll need to move the chair right in front of Miroslav back, just a little bit, or the person's head's going to be cut off.
Oh, this one right here.
Yes, just back towards the chalkboard. Oh, perfect.
Yeah.
Okay. Okay, faces. Can you have the slide bigger? Faces. Yeah. So, welcome back. I am happy to introduce the panel of experts who will be questioned and criticized and provoked about all kinds of different things. Okay, so here they are. Andy sends her regrets. She hasn't been feeling well for quite some time now, so she couldn't come. Then we have Rebecca Carter and Peter Taylor from Queens. So they're one team. Taras Gula will have to do it on his own because Andy is not here. And then Sarah Maestang and Bernardo Gavao Sosa will have their own thing. Okay. So we'll have 3 rounds of questioning, and each group will be given some time to develop their arguments, answer questions, and after that we'll turn to you and questions from the audience and questions from chat. Okay. So we'll start round 1. So the first thing, so for each of you, if you wish to have a quick introductory statement before we start questions, is there anything you would like to say? I'm putting you on the spot because that's not part of the script. Okay, so Taras, anything you want to say before we start? No. Okay. Anyone else? Yeah. Yeah, can you test your microphone?
Test the mics.
Yes.
Is this working?
Yes, it's working.
Hello?
Test.
This working?
Yes,
Okay.
Rebecca?
How about now? Good? I might also give some context for our course because we'll be talking a lot about a course that we developed. So we were working on the largest calculus course offered at University of Toronto. Enrolls between 2,000 and 3,000 students a semester. It's first year calculus service course for students who are, I think the easiest way is to say students who are not going into math or a quantitative subject or commerce. So there are other calculus courses for that, primarily biosciences students, although really they major in everything. It's kind of the default calculus course. So a lot of students end up majoring in math, curiously enough, but it's the default calculus course. So we were working on redeveloping it. So that's the course that we'll be referring to.
Okay, anyone else?
I guess then I'll give the perspective
Yes.
because I'm speaking, well, Andy's not speaking for the numeracy course that she developed at UTM, and I'm speaking from a college math education perspective. So there's a numeracy component to that. So that's where my thinking comes from.
And we're talking about service courses at Queen's in either calculus or linear algebra.
Okay, thank you. Okay, so now let's start the formal thing in order. So first, it's stars and on numeracy. Questions are, when you say someone can think with numbers, what does this mean? How do you know somebody is numerate? And what characteristics does that person have to possess in order to be numerate? 3 minutes.
Yeah. So I did some thinking about this, and so the idea of thinking with numbers, so you have numbers along the side with you kind of thing, right? And so that's one approach I was taking to this. Really, it's about measurement. Thinking with numbers is about measuring. So that's a perspective you bring to whatever you're doing, right? So I'm a numbers guy, so I love having this watch that tracks not only my heart rate, but my heart rate variability, which is really cool if you look it up. And so, so that's thinking with numbers. Meanwhile, I have a son who's not a numbers person at all, so that would be kind of so I played around with that idea. But there's nothing really definitive in terms of thinking with numbers, except maybe a predilection towards that. And numbers as tools and aids does not necessarily mean that you always are using them. So our society kind of tends towards that. Thereby we have these watches that track stuff. The question about how do we know somebody is numerate? And so Miroslav and myself have been struggling with this question and the whole idea of numeracy for a while. And right now it's, and I wrote it down actually so that I wouldn't screw this up. To be numerate is to be comfortable. So that's, I think, one of the really interesting things. Comfortable with switching back and forth between being in the concrete and being in the abstract. So we call them concrete and abstract thinking spaces. So those of us that are good at switching, I'm putting myself in there, but I don't know. Those of us that are good at switching back and forth would be those that would be considered numerate. And sometimes what that means, and what I've been noticing in myself, is kind of you're in both places at once. And so that's, I think, maybe a way of defining or trying to come up with a, did I get all of them?
Good,
Is
yes.
there another question? Okay, good.
So actually there is something to connect. The first talk that was about physics, yes. Interplay between physics and math. That's also our brain having to be at two places at the same time and constantly switching between one and the other, right? That is hard, right? We agree on that, but it's also extremely beneficial. Okay, thank you. Okay, Sarah and Bernardo, what does ACT stand for? First question.
Applied communication tasks.
Applied
communication tasks.
Tasks, okay, thank you. Okay. So you have been working on those ACTs for a while. What's your motivation to design such a course? What's missing in the existing math courses for students who major in sciences?
Yeah, so I think that the initial idea for this was consultation with other departments. Back when I initially was thinking about redoing this course, it was a very, very traditional course, hadn't changed in, since about the 1970s. And we talked about topics, but I think one thing that really stood out in my mind across these is that students in their later courses were scared to approach math in unfamiliar contexts. So if they got a scientific paper that had some math in it, they were like not only didn't understand it, but they were like scared to even dig into it and see what they did understand. Now, in some students, I think that lack of confidence was maybe actually a lack of intellectual humility, but that was a problem that we really wanted to start to tackle. So kind of using backwards design and thinking about where we wanted students to end up, I started to think really big. Like, what was the big thing we could get them to do? And ultimately, the big thing was take a scientific paper. So we had 3,000 students. Each of them choose a different scientific paper. They didn't end up working in groups at the end, but they started with each a different scientific paper, and that had some math in it, some calculus, either some integral or a differential equation. And their job was to make a scientific poster that they could present to the public and tell us about the math and the context. And then this also arose, so there's an application in there, and there was also a lot of communication, both reading, writing, and speaking as part of that task. And it also grew out of consultations with English language learning specialists. And maybe I'll have Bernardo speak about the rest of it.
Yeah, so I want to say most math courses focus on like a few things, like calculations and algorithms, like derivatives, inverting a matrix, solving differential equations, etc., or proofs. That's another typical mathematical thing, and now there's appearing more modeling with math, but they miss a lot of this communication aspect. So I think that was one thing that we were trying to focus. Like Taras was saying, like this being comfortable switching from the abstract to the concrete. That was kind of the idea. We want to train, to get students to become better communicators. And communicators, we take it like the sense where they should be able to read abstract, concrete ideas and translate into math, be able to write and to speak. So these ACTs, the applied communication tasks, they will focus on these three aspects of learning how to read. So that's part of what Sarah was saying. Take a paper, read a paper, understand what the paper says, and then writing and speaking when they're actually creating the poster and presenting the poster. So there's like all these three aspects. They're like broken down in these tasks. So that was, I think that was this big idea of adding this extra layer of communication to math courses that's not commonly there, and developing through these three aspects of communication.
Okay, thank you. Peter, Rebecca, would you like to play your slides first?
Not now.
Okay, all right. Okay. Okay. So what does it mean that something in mathematics is authentic? Does authentic apply only to service applied math courses? And if not, what would it mean in abstract math? And why is authenticity important for service courses?
So Peter and I, we've spent a lot of time talking about what it means to be authentic and going back and forth and sometimes disagreeing. But I think where we've arrived is that an authentic experience is one where you're working with rich structure, but also has an element of simplicity to it. And it's in that we find beauty and wonder and all the real and great things about mathematics. We also, though, look to the fact that beauty is diverse in nature and how it appears in mathematics, which is part of it being authentic. Francis Sue, I think, gave a really great description of some elements of how diverse this can be. Sometimes it's in applications, sometimes it's in rigor. And so it's important in providing authenticity that we are also including that diversity of problem. Thinking about, is it also in pure math courses or abstract math courses? Authenticity, I think we see is in how we deliver, but also what we deliver. And in some cases, in these abstract math courses, the what kind of already has an element of that authenticity a little bit easier. And that we actually find that the challenge is in the service courses. How do we also be working with things that are that nature. Is there anything?
I will say that we've been developing these authentic math units for some time, working with graduate students, a few undergraduates, some teachers, a postdoc, and our measure for authentic is if we start with a problem, we want everybody's face to light up and they just can't wait to start working on it. That's an authentic math problem.
Okay, thank you. So I guess one common denominator here is really this authentic stuff, right? But we don't mean the same thing by that, right? So we've heard, I mean, authentic within numeracy is actually very different from what you said. Okay. Okay, before we move on to round two, can we just clarify this a little bit?
We all disagree with that statement.
Yeah, okay, so why do you disagree with me?
I'm not sure the authenticity within numeracy authenticity is some. Can you use the microphone? Sorry. Yeah, so this is a little off on the tangent here. We're disagreeing again, but yeah, authenticity is not what was driving the ideas. Maybe coming up with an authentic numeracy task, okay, maybe. So that, like in that framing, maybe, but that was not like, what is it to think with numbers authentically? That's not what I was thinking about even. So I don't even know if that's.
No, I mean authenticity of context, for instance.
And math is a context, right? So that's the other thing.
Now we are getting into philosophy. Peter, do you want to say something more? Okay. Rebecca, you guys? Okay. Round two, it's the same question for everybody else. Okay, so there's a quote: education is to teach young people to desire the right things. This is ancient Greek stuff, i.e. justice, morality, courage, wisdom, and moderation. If this is our end goal for a math course, what are the right things in your proposed course? What is the value of teaching the content? Okay, go ahead.
Well, the first thing that I think about is the attitudes that we're presenting towards mathematics. And it starts with the values towards mathematics that we hold and how, and I think that really requires thought on our end. One of the mantras that we try to instill in our instructors is that for most of our students, this is the last math course that they'll ever take. So they're within like the last 100 hours of instruction in mathematics. And they're going to be future citizens, decision makers, scientists in our society. They're going to be future parents, educators themselves. And what attitudes about mathematics are they going to hold? And I think like if we look at the dialogue in the last presentation, there were a lot of attitudes that those students were holding towards mathematics. And the very first thing I want to instill in my students is attitudes towards mathematics. And of course, that starts with, if you're doing a large course, that starts with instructors and TAs. That can be reflected in the policies that we have in our course, and really re-examining traditional assumptions in our curriculum. But that's one of the real things that it reminds me of. Yeah, so I will stop there. I could go on and on and on about this, believe me, but I will stop myself.
So we're talking about most of the applied communication tasks, because our course already kind of focuses on using, I would say, authentic problems. Maybe the students are not jumping out of their seats to start them, but they're grounded in reality. Like you won't see, find if this function, like if it's an exponential with numbers like 1, 2, 4, 8, 16, there will be the prices of lithium batteries in the US over the last few years, and have been growing exponentially, or decaying, I guess. So this is the kind of things that we study in this course, throughout the whole course. And these applied communication tasks, I think they give like a platform for students to immerse themselves into things that make sense, that they care about. Also in terms of justice, morality, like the quote. And so I'm just going to talk a little bit about 3 students that I had this past fall, and so Sarah talked about one of the projects we had for the ECTs, creating a poster. That's usually done. We do this in the winter term. In the fall, we have a different one where the students are tasked with modeling the population of their hometown. So they get data for the past 20 years, and they have to kind of project what's going to happen next year, in 20 years, in 50 years, in 2100. The whole point is in 2100, they'll get absurd things, and they should try to see why that happens.
And the communication portion is they have to convince a different audience about their point.
Yeah, so I had these 3 students, and one of them was a funny story because I met this student before, and she's kind of like an activist type, and she came to me because the instructions are you have to model the population of your hometown, and she came to me and was like, I want to model the livestock population in the US, and I think she was like, you could see she was like stealing herself for confrontation, and I just turned like, okay, that sounds great, and I was like, what? It's okay. Yeah, so that's what she did. She, instead of the population of her hometown, she did study the livestock population in the US, and she had all these things about animal rights and all these ideas that she included in this project. So that was one thing. Another student modeled Toronto homelessness and included factors there in the modeling, like cost of living and inflation and things like that. So something definitely that's like close to her heart. And another student it was hard because this was an international student, just came from Gaza in the fall. Everything was fine at the time, and then suddenly the war broke out. Her family was displaced, and she was at some times like she couldn't work because a week had gone by and she hadn't heard from her family, so she was quite distressed. And this project she was not happy at all, because if you look at the past 20 years of data from Gaza, you're ignoring the whole displacement that was really like bothering her. So we worked with her so that what she ended up doing was modeling what the population was for the last 20 years, what would have been, and then she studied what's the Volograd. It was Stalingrad, which in 1949 it was decimated by the Battle of Stalingrad. So she tracked how the population of Volograd now, Volograd, how it recovered afterwards, and she kind of created a model of how the population of Gaza is going to recover in the next few years. So just to give like some examples where these applied communication tasks give like this platform for students. Most of them, they just do the standard things, but some, they care about something more deeply and they actually take it seriously.
Okay, thank you. Well, Taras?
I would add, so first of all, this was presented to us as Stoics, and I wasn't sure about that, so I looked up a bunch of stuff, but I have a few Stoic things that I have in the back of mind that I bring to students. One is learn to enjoy the things you already have, which I think is really important these days. Play, and this is good for mathematicians because that's where probability theory came from. Play games you know you'll win, and key to happiness is low expectations. And those are complex things to bring into the classroom. So the only way I could really frame it is the idea of slowing down your thinking, because each of these statements makes you think, like, what does that mean, right? What is the key to happiness is low expectations? Does that mean I shouldn't do anything? Of course not, right? And so, but having low expectations when you hand a test paper in, what will your mark be? Well, I don't expect anything to come from for free. Whatever's there is what I'll get, and so I'm not going to lose sleep over it. So that kind of but it comes from slower thinking, taking a step back. And so when bringing this kind of numeracy perspective into courses, and one of the things, so this is not the last math course they'll ever take kind of thing. I never think about it that way. This is like, there's no math kind of, because it's not about the math, right? So these courses are not about the math, they're about other things. And so I can bring in, and I've tossed a bunch of mathematical equations out of various courses at the college level. And being able to calculate them, especially because I want people to step back and think, okay, where do I need this? What do I need? And I'm not sure if this is a good thing or not, but trying to be aware of your own thinking while you're doing solving these problems that are presented. And so can't say I'm an expert, even though that we were all said here as experts. I've done some thinking about these things, but I can't say I'm an expert in terms of how to make this work in a class. And so one other thing I wanted to say, the discourse and the communication. So Igor's presentation, and that's what I'm actually reading. I think so. One of the people that wrote about this was Anna Spard. Talked about discourse, and so trying to get a sense of where the discourse is mathematizing and social, and how these things help build when you're talking about these students that, we love having these students that go the extra few steps. Now, how do I get more than to do that, right? How do I build a culture of that through authentic, right? Something when you say everybody's eyes light up, how do I build that kind of culture in a classroom? That would be, beautiful if I could know how to do that, but that would be a goal. And I don't know how it fits with Stoics, but because they're kind of weird, right? Stoics are weird, and actually we have we don't have a lot of writings from the Stoics themselves. A lot it's about people writing about Stoics or taking on the philosophy of the Stoics later.
But low expectations is definitely there, right?
Well, the coolest thing is when you go to sleep at night. That I heard about Stoics is you go to sleep at night, you don't expect to wake up. And then you wake up in the morning and you're like, wow. So you're not thinking I'm tired, it's raining, you're thinking, wow, I woke up. I didn't expect to wake up. This is great.
Yeah.
So same thing when I guess as teachers in class, when we walk into a class, we expect them to hate it.
Yeah.
And then we're like, we have 5 students who love it. They go, oh, yes, 5.
I mean, that's definitely a good approach, and I agree. Yes. Okay, so Rebecca, Peter, we have your slides.
Yeah, so I mean, when we're thinking authenticity, I think we're thinking about what our students are doing in service courses, but also how they are working. And so for us, the how is play. We want there to be time and space for mathematical play, which also really includes the attitudes that we're sharing with the students. But that then brings us to a big question, which is, what does the content of our courses look like? So that we can have that experience.
Okay, I'm going to show you 3 pictures of trees. That's the first one out of a paper by in the notices, and that's actually a tree. It's on its side, but the horizontal lower part is the trunk, and that's the standard prerequisite for all the branches, including at the very tips of the branches on the right-hand end. That's where the mathematics is. That's where mathematicians work. They work in the branches, and that's where the fun stuff is, and that's the arena of play. Whereas the trunk, it's much harder to play when you're climbing the trunk of the tree. And so this paper says, well, we don't really need all that, and we'll support that in a second. And because we want our students to get up into the tree. And the next slide is, is a tree. This is a paper of Dan Kennedy. He's talking about the high school, but he's saying the students mostly in high school, certainly in grade 11 and 12, are really trying to climb the trunk. And they're constructing a ladder, in a sense, in this paper, so that they can get right up into the branches. And that's okay, that works. And then the next slide is the little girl is up in the tree, and this is an interesting paper by Wiggins, and it's saying just let's suppose that you don't really need so much knowledge. In fact, you need to know how to perform, you need to know how to play, and play is, the branches are the playground. And there's quite a bit of literature. We could just look at some of that literature. That next slide, that supports this. Keith Devlin has an amazing article, really, in which he says, he's about my age, so he went through university at the same time, King's College, and he learned a lot of things which would really equip him to succeed in the future. And he's saying just about all that stuff is now irrelevant. And what our students actually need is the skills and the understanding to be able to perform, to be able to use the benefit of those wonderful machines that we now have. So, and next slide. And well, that's our Math 126 course at Queens, the second half, and that's a trunk. There's a trunk. You can't read that. It's too small. That's purposeful. It's not the kind of thing you want to read. Next slide. And Papert, so work at the MIT Media Lab in the 70s and 80s was really wonderful, and it was focused on play. It was focused on the importance. We all should be children. We all should be playing, and that's what you need to do math. And the students who come into our service courses who do not do well, it's not because they don't know enough, it's because they haven't learned how to play with mathematics. Next slide. Okay, later we'll show you this as an example of being up in the branches. Okay. Any more to add?
I think you got it.
Okay, thank you. Any comments on each other's answers? Okay. See, there's one thing that actually you said, and also we heard before, is that this is the last math course the students will take in university. Just think about it. Why is it like that? It is because, at least at my university, every single department makes a conscious effort to avoid mathematics as much as possible. There is absolutely no reason why kids shouldn't play with mathematics in the social sciences or in the humanities course, but they don't, right? So the way mathematics is viewed is a box, and for many students, I just want to get rid of it, and then I'll be okay, right? It's just one of the hurdles, right? So it's none of that tree stuff, right? It's actually, it's painful, it's misery, right? That's how most of our students feel about it, right? So what I'm just trying to say, and it kind of probably will come up maybe in the answers to the last question, is that we can't fix everything, right? There are general attitudes about mathematics that are far beyond what we as mathematicians can do. Okay, Mami, you can contradict me if you want to. Okay. Okay.
Can you read the question? I also wanted to comment on what Peter was saying about this idea of service courses as being this place of play and exploration. Just over the last year or so, the conversation in other areas of education about, what do we do with AI? What are we ever going to do? And I think a recognition that other areas of education need to change. They have really driven towards this idea of giving students the tools that they need to explore the world after. And they finally realized, I think, that we can't prepare students for the world ahead. And this is a conversation that service courses have been having for decades and decades. So I think that maybe the way that we approach service courses and the things that we have learned to do can be a model, actually, for what other people are now experiencing in this, I don't know what we'll call it, AI, whatever world crisis, I'm not sure.
Okay, can you please read the question?
Oh, okay, I didn't see it. No.
But I'll read the first question in the chat. Can the panelists reflect on how their work affects the ability of the students to effectively engage in meaningful discussion of public policy issues as citizens in a democracy, e.g., public health matters versus individual rights, climate change versus short-term economy, inequality versus meritocracy?
Okay.
Sorry, can you speak into the mic, please?
I think we heard you in here, Paul. Let me try it again. Is that right? Okay.
No, but they can read the question.
Yep, we can hear you now.
Okay. Okay, so we'll go from Bernardo this way. Go ahead.
Let's see how our work reflects scientifically engaged. So I mean, I think what I try to do is kind of give students a platform where they can engage with things that they care about as citizens of the world. I don't think it's not something like we provide like a safe place where they can do this. They're not going to be really judged. It's not going to be online where people are going to criticize and do stuff like that. And we'll give them a way to practice on how to communicate about these tasks. And then we're grading them more on the communication, not really like the examples I gave. We're not really grading on the appropriateness of what they're doing. We want them to feel free to just use different factors when they're modeling these ideas, when they're discussing things, and that's what we're trying to do. I think it's just provide them a platform to practice, to train in a safe place, so that when they just go out there, they're better equipped later to express it, like to the general public. And I think that's an important thing, to learn to become better communicators as a whole.
So I will also add and say that I think that part of it is communicating through the examples that we give. So we pull most of our examples from scientific papers, and I purposefully do a lot of examples from women's health. I had a little bit of a revolt early on in my teaching organization when I had a team of male instructors and I had something related to a menstrual cycle proposed on the exam, and they said that would be unfair to the men. Can you imagine? But you know, I think that but you know, I think that part of it comes into that, like that sort of like activism in terms of what examples we present. We also had a series of tutorial examples that we developed with a chemistry student who was doing environmental chemistry. And a lot of our tutorial examples are on that. I talk explicitly about bias in science and bias against different people in science. So I think, you know, we can be very explicit in our values.
So two things. One is that when the course is structured, so in some ways service courses, and that's what I do in terms of the colleges, that's what we do in the colleges. We don't really have mathematics courses out there like mathematics. So they're about the thing that the students are studying. And in that way, the problems that, if we do it right, which means that jiggling between those two areas of abstract and concrete, then that can be applied to many different areas. So, but we have to do it right. And I think that idea of play, which is somewhere in the back of my mind, but now it's made a bit more explicitly because of your talk. I think so when playing around with the numbers that you see, so not necessarily skeptically questioning them, so not training students to do that. There's a kind of critical thinking that people talk about, but playing around with the numbers, like, oh, where does that number come from, right? Where does that number, how does that actually get produced? And so, and having knowing that, well, I may not know all the math, but I can still get my brain around kind of what those rates and the stuff that gets published in the headlines, what it means. So I think that's an important thing that we do at the when we do things right at the colleges. Now the second thing, so specifically in a math course that I did, which is really cool, and I was blown away by what the students produced, was I created during the pandemic a diversity in mathematics assignment. And it was like, you can do anything you want, you can write a paper, you can do a presentation, you can write a poem, I don't care what format you do it in, and I don't care what it's about, but it's got something to do with mathematics. You can say mathematics is a tool of oppression, you can say it's a tool of liberation, you can highlight a mathematician from whatever part of the world that I've never heard about this person before. I don't care. And the stuff that students produced at a college, right, which I was blown away. First year, these are not, mostly students are not straight out of high school that I had in that course, but wow. And so giving students the opportunity, right, and they trusted me, I guess, that they could do anything. So I had songs, well, not too many, and I had a couple of poems. They weren't that great, but they were okay. They were okay, right? and it was fun. And so I think that, yeah, students value that. So there's various ways we can do it, little ways. I don't know how we can do it big, right? Because you have the syllabus kind of thing, and that's still hanging over our heads. So.
I think if we try and move away from, as you're describing, this box checking mentality for these service courses, or looking at the long list of procedural knowledge that we're trying to cover in a short amount of time, and instead are inviting students to play, that's where they really can develop skills like rigorous thinking and building arguments, but also identifying what is a good argument and the bounds of an argument. And those are the sort of things that I do think will help students navigate like this very complex world and information that surrounds them.
Okay, and so the concluding round, so on numeracy first, is it possible that an undergrad who knows mathematics is enumerate? And if so, how can you fix it? Yes.
So first of all, it's not a yes or no thing, right? Numerate, yes, you're numerate, you're not numerate. That's another kind of box checking kind of question. So it's kind of a sliding scale, maybe. I don't think we know how to measure numeracy. Sorry, there's all these tests out there and stuff, but the more, you know this, we played around and dug around. We're like, well, what is a good numeracy task? I don't know. Well, I think I know right now, but I don't know how to produce one yet, so to speak. And so I'll throw, I was just thinking about this because I had COVID last week, and I did this thing where I did, okay, so I wanted to be negative, right? Because I wanted to, I play hockey, I wanted to play hockey on Tuesday, so I wanted to be negative. I was feeling okay, old guy hockey, so it's no big deal. And then, so I had one test, and I'm like, oh, it's 20% false positive, right? Sorry, false negative. So if I do two, right? If I do two and two different brands, right? That should be more strongly negative. And I'm like, how do I do the calculation? Oh, is it? And then you're like, hold on a second. Then I start reading about, and I'm like, what? This is more complicated when you start thinking about the actual tests and how when they report, right, the false negatives, what they're basing it on. I don't think it's the tests that are failing. They're just, and my wife said, well, if you want a false negative, just don't put it in your throat, put it in your nose and you'll be fine. Right? So there's ways. Anyway, so, and so I thought about it as a numeracy question. I don't know if I'm actually doing students I'm inflicting diagnosis, the specificity, sensitivity, all that contingency table stuff on Tuesday with the students. I was saying this would be perfect because it's that kind of test, the predictive test. And so anyway, so I just throwing that out there as, yeah, numeracy, how do we measure it? At some point, I think I would like to be able to get that jiggling between concrete and abstract thinking places and get how do we capture that?
Okay, thank you. So Sarah and Bernardo, it's about your course. So given that your class is huge, how do you assess writing? How much time do you spend marking? And is there anything you would change about your course?
Okay, so yeah, there's a lot of grading that happens. I was doing the calculations for this, and it's about a quarter of the TA hours we have are done used for grading these applied communication tasks alone. So that's quite a bit, but we have a ton of students, and that's still not a lot of students. I think that was, we talked about, it's like 18 minutes, 19 minutes per student, I think, 19 TA minutes per student. But it's not a lot, but it's still like a big, huge part of our budget. On top of that, I have like one head TA that was working mostly with ACTs. I had one instructor that was also working with that, and we have the Faculty of Arts and Science has this thing called lead writing TAs, that they're trained to train TAs to be able to grade communication tasks, because it's not something that math grad students know how to do. So we have also a lead writing TA that's assigned to the course and works with us and the training and all that. So it's a lot of the course, and still it comes down to very little amount of time per student. So what would I change? I think mostly it's not the grading, it's the support we can give to the students. I think the students have there's not a lot of like one-on-one support. So I think that would be the first thing. Increase the budget on TAs so they can meet with the students like more one-on-one. It's hard because it's, like Sarah said, between 2,000 and 3,000 students. Even on some of these tasks where they work in groups, it's still like half 1,000 to 1,500. So yeah, so I think it would be more time for TAs to meet with students one-on-one and to prepare TAs better. We have a huge range of TAs, from some that embrace it and they love these tasks and they think they're great and they really care, and the other ones that think that this is a waste of time, they should be learning derivatives and proving epsilon delta proofs, and it's a waste of time, and so they don't really get into this, and there's this difference in experience from students because of that. So improve these two aspects.
Yeah, and I think one of the things that I want to emphasize, I think about the entire approach is that when dealing with a large class, if you want to do something ambitious, you have to start with the end goal and not really think about the class size. Like, I'm a pretty strong believer that you can basically do anything with a big class that you can do with a small class. It's just about how you do it. So starting with the end goal and really like thinking about what you want to do and drilling all that down before you think about how you're gonna do it. Because the how, like if you started with the how, you would never do anything. We usually we have
low expectations, you know.
Yeah, well, I started with these in 2018, I guess, 2018, and I don't know. And then I coordinated the course for 4 years, and then we had a year of overlap, and the pandemic year was our year of overlap. I mean, fortunately or unfortunately. And then Bernardo has been coordinating for 3 years, 3.5 years. And over that time, a lot of things have changed. So during, we have tasks that build up to these final tasks. Like, we have a 5 communication tasks, there's 6 of them over the year. The tasks have changed, but the logistics have really changed. We learn lessons, and every single year there are, every assignment, we have like hour-long meetings just about how are these things going to get from the student to us to the grader, without even talking about grading. Like, just how are these things going to happen? So it's just a lot of work, but that's at the back end. Don't think about how you're going to do it at the front end, or else you're never going to do anything good. That would be my advice to large course coordinators. Don't get scared at the beginning. Do it at the end. Just go for it. Panic at the end. But you can do it. It's kind of fun, actually. Figuring out how is this going to happen.
Yes, and forget about your life and your family and everything else.
No. I always quit work at 5. I began work very early, but I always quit work at 5.
Okay, and finally, Peter and Rebecca. So you had these wonderful ideas about play and puppet and all that. Can you give us an example of?
Yeah. So next slide.
Oh.
Yes. So.
Put up the one with all
the. Yes, exactly.
Well, I'll refer to that because Becca and I plan to teach that course next year. That's a standard calculus course, and we'll do it differently. We'll get the trunk reflected into the upper branches. And so here's an example of a problem. So the problem is build this. So can you click on the Desmos thing there? So we use Desmos because it's just a question. There's no coding bar. Everybody can do it. And so if you run the time there, the challenge is for them to build a circle that rolls around the inside of a parabola. And we've been doing stuff with students where they roll a circle around another circle. But they run into trouble doing this. Yeah, run it again. Yeah. I mean, so they run into trouble doing this. Why do they run into trouble doing this? They've already learned how to roll a circle around another circle, which is kind of fun and neat and all that. Why do they have trouble with this? Sorry? Well, this one does. If the circle, if the little wheel, the red thing is a wheel. If the wheel is too big, it doesn't. But this is small enough that it fits in the parabola. That's an excellent thing, excellent point, yes. And that's another problem we give our students. But they have trouble. They really have mastered. I mean, building this does another thing we haven't mentioned about the life of a mathematician. When you try to build this, you have to be careful and precise. And a lot of our time doing mathematics is about the details, just being very careful. And that's really in this problem. But there is a problem they come up with, even though they've mastered rolling a circle around a circle. And that's, there's a little marker point. Can you see the marker point all right? Yeah, there's a little marker point. And it's got to turn at precisely the right speed to give you a sense of no slipping. And it's amazing. If you change the speed of the little marker circle a little bit, it doesn't look right. It looks like it's slipping. And so you've got to get the speed of the marker point just right as the wheel moves. And the problem for a grade 12 student, because we've done this with grade 12 students, is about arc length, right? Roll the circle back a little bit and stop it. Because you've got to, the amount of movement, move it a little bit, stop. Yeah, so there's two curves there that have to have the same length, a red one and a blue one. So you have to understand how to find the arc length of a piece of a parabola. And that's one of the ones, arc length was in that awful tree thing that I didn't let you read. So here's a reason for arc length. Arc length is actually reflected in one of the branches of the tree, because it's used to produce a beautiful, powerful thing. Therefore, this qualifies as a piece of the trunk that actually will go into our course.
Okay, thank you. Any final words before we turn to the audience? Okay, thank you. Are there any questions online?
There was, but I think we're going to take it.
No, we can take it out.
Do you want to, I think it was, we had one, that AI question, so let's go back here. Yeah, so it was Igor. What is the role of AI in your courses or our courses, and what should this role be? That's the question.
Yeah, go ahead.
So I do testing mostly in we use OneNote. So OneNote class notebook, and they have a little calculator there that I can actually draw. I can't do this, and I tell students, I don't care how you solve the problem. So, and I have students that submit stuff with ChatGPT, and it's very clear. Like you read it and you're like, whoa, this is like, the wording is like weird, right? And I say, I don't care if you use ChatGPT, but boy, oh boy, this is what you wrote here, half of it is nonsense. So then we talk about it, and then they don't do it next time usually, but yeah, what's the role of AI? I mean, it's that kind of magical black box that does a lot of the stuff that we don't like to do, I think, right? So, and I've asked nephews and other younger people that, you know, what they do at work, and they use ChatGPT, but mostly, and they never put anything out straight from ChatGPT. They just kind of, oh, I got 500 words here. I only need 100. Can you rewrite it as 100? And then they read it over to make sure that it's getting across the meaning that they want it to. So I'm not, personally, a lot of people at college, we were joking here that AI questions are going to be the highest. A lot of people in the colleges, and Cameron can attest that, are, you know, perturbed by it. And in the math education world, I think a lot of people are perturbed by, oh, the machines will do the calculations. Well, as Devlin said, they've been doing it for years. I'm not worried about it.
So I think ChatGPT it's an interesting case because it's not it's like an AI that uses it's a large language model. It just does statistics with language models. So it has some problems with math, at least for now. The truth value, if you give something that's truth, you ask it, it might not come out truth or the other way around. So I think that's great for now because it's students have to be really careful, and it becomes really obvious when they do math that it does weird mistakes. Like I put around, my daughter has a homework assignment and I put it there and I switched a little bit and I made a mistake. And this is like a sixth grade homework assignment. And it does like n+1 cubed, it did like the wrong thing, which is like, it's like an easy thing for a computer to do. So I think that's kind of, it's an opportunity for now because it's not very good. Students don't really trust it as much for math, so they can use it more like a study partner. We can ask questions, it gives you back, but you have to be careful. You have to actually read it, see if it's telling you the right thing. It's going to be much worse when it gets really good, and then they just, it's good. I don't even have to check it. So I think that's what's happening more with English and with essays, because they think it's good, they just submit it. And then we did have on some of the ECTs a text that said, with brackets, put your hometown name here. Put the number of the population 2020 here. And the student just submitted just the same without substituting things. So we used in our course, we're using, I had questions with ChatGPT on a test, like a student wants to solve this question, put it on ChatGPT, and I put a screenshot of what ChatGPT does, and now they have to assess what's doing wrong and why, and maybe how to correct it. We had a couple different ways to do this. So kind of like right now, I don't like to just forbid to use something that is going to be useful. Everyone's using it, but then my approach is more, well, I want to pass along the message that you can use it, but you have to be really careful. You have to test what it's doing. You have to make sure that it's doing the right thing in the end. So I think for now, ChatGPT is not great, and that's a great opportunity. When it's better, it's going to be harder.
Okay, thank you.
I think, I mean, you brought back to what Devlin had said there, and it is about, I mean, these things do exist and they are going to continue to get better, but it's about equipping students with the ability to use them well and not just taking it for granted and submitting what it spits out, but knowing when to use it, how to use it, and also being able to critically look at what it's spitting out, I think is part of it.
Yeah, this last part is difficult because, I mean, if you look at ChatGPT, it's built on neural networks, right? And what's actually happening inside is not at all insightful, right? So for instance, they say one of the biggest problems is eliminating bias, right? It's not so easy to go to look at the computer, where is that bias created so I can remove that part? So it's not that simple. So I think one of the problems, and actually it goes back to what you said, if our students want to understand it, they have to understand the fact that this is a huge black box, which is very hard to understand, and that could be extremely unpredictable, right? It will confidently quote, I tried it once, 3 or 4 references on certain subject. When you check the references, well, they are kind of not really related, right? Okay, so let's see, any questions, comments? We still have some time before lunch. Yeah, okay.
Folk has a question.
Thanks. That was super interesting. I have a question, and maybe directed toward Sarah and Bernardo, because I think at least Peter and Becca, you've maybe responded to it with this example. I wonder if, as mathematicians, we aren't displaying some expert bias in wanting to move away from the box checking of say calculus. So maybe it seems like box checking to us, because to us it's so basic. And we want students to get excited, which is great, but we have convinced ourselves that calculus is non-exciting. So maybe this is like a reflection, not of our content, but of our cynicism. So my question is, essentially, is this an us problem? Like, can we teach, do you think we can teach calculus, basic calculus, in an authentic way without any swing toward like contemporary applications? Is that possible, or would you not recommend it?
Yeah, so I think that yes, definitely is. So we were really asked to focus on the ACT part of our course, and so that is what we've been speaking about. But I don't view calculus really as blockchain. I think it's a lot of it is like, you know, the things like complex integration techniques and things like that we would never do by hand now. I don't think we should ask our students to do unless we have a reason that it is developing some intellectual capacity or that we can find an intellectual need for it. But I'm a pure mathematician. I get excited by that aspect of it. I don't actually get very excited by the applications, to be honest. Like, I am motivated by the pure aspect of it. So I think that when we actually teach the concepts, we are not just doing applications. I think that it's not a. I think this is a complicated thing that I struggle with because I don't want it to be an add-on. I want it to be integrated, but I also want to find an intellectual need outside of applications. Like, so I forget. Someone in the room will know where intellectual need comes from.
It's a framework from Harel, the Israeli scholar. So it's about repeated reasoning, dual ways of understanding and knowing. So it's got I forgot this. I forgot the short form, but it's basically saying students have a needs for computation, needs for reasoning, needs for calculation, so stuff like that.
Yeah, and I don't think we're just going to be able to present them with like, oh look, you might need to use it when you are in a chemistry lab, and someday like that's not authentic. So I do think that needs to come from mathematics, and that is why we as mathematicians need to teach math. Why we can't hand it over to science.
Yeah, there was another question. Christine, do you have a question? Sorry. Go ahead.
Let me just say, folk, that's a great question. I regard this as a time for all universities in many ways to be reflecting on change and reinventing themselves and to be asking exactly that kind of question. And that's what we're going to do. As I said, we're going to try and teach this course, and your question will be one of the ones we're struggling to answer. Yeah.
Okay, thank you. Good.
So knowing some of you who are on the panel, I view the panel as being fairly unique. And I think my question is, how unique are you? So in other words, if I were to be talking to secondary school teachers, students, parents, and they were wondering, so what kinds of things they might expect in a first-year calculus course, and what kinds of things would their professors value, would this be something that we would see kind of shared by other professors of that course, or would you say that, you know, your flexibility, your willingness to have students play, try different ideas would be fairly unique to the group who's here and a few others, or fairly persistent across the range of professors?
Thank you for the provocation. So who wants to go first?
I can speak for Ontario colleges is that we don't know. We don't know because we don't know. Many colleges don't have math departments, and so with the so Cameron is involved as well. So one of the things that we're trying to do is to try to build some sort of research to find out what's going on, or what do people think, what do people do. And unfortunately, my suspicion is that many full-timers, when they leave, are being replaced by part-timers. And the part-timers are box checkers because this is a step towards something else. And so they don't have the time, and they're not asked to do anything more interesting. And so that's a beginning of an answer to the question about a suspicion rather than really knowledge.
So that's a great question, Chris, and that's actually related to Folk's question. For our math major calculus courses are taught by professors, and I won't go there. Our service courses are generally taught by postdocs, and they're not sure what's expected of them. And just this year, I've done quite a bit of work with our calculus postdocs, talking about the trunk and the branches, and so that situation could be changing a lot, but it's a really good question.
Yeah, I would also echo what Peter's saying. I think at U of T, our focus is really on training, and we have a great team. I think all of our first year calculus courses, except for the one for math specialists, won't go into that, has this sort of philosophy now. We have a great team of colleagues who have been working on those. But then we also really put an emphasis on training, and almost all of our instructors are new to teaching, and we have a lot of TAs, so huge teaching teams, and I think we've really seen the teaching culture change as a result of that. So, as Peter said, maybe there's hope for change, but yeah, and I think the discussions are changing around universities too. It's hard.
Okay, one more question from our audience.
But they evaded the question. So, are you unique or not? Okay, good. Okay, go ahead.
Sorry, I have a poorly formed question. Trying to think through. That's fantastic. It's gotten me really thinking. Maybe it's a bit of a question for Peter and a group. Maybe it's for everybody. We were talking about prerequisites and service courses, and there's a lot of talk about like the last math course they ever taught, and a lot about play. And something I've noticed is I'm curious if there's still a place for a trunk for the fundamentals and the things that they actually do need to learn, right? Like it's one thing to play with this equation, but if they don't know what a parabola is or what a sine curve is or anything like that, there's still a problem. So I guess my question is, like, are we like saying that we need more branches among the trunk, but there's still a trunk and there's still maybe an evaluation piece missing that they need to get past the trunk to be able to, not to be able to play, they still need to be able to get past the trunk to move up those service courses. Those things are still fundamentals that are missing.
Well, I mean, in this linear algebra course that Peter and I have been working on developing and teaching this year, we do a lot of play in the class, but we did get feedback from students who they wanted more resources to help them with some of those technical skills, like just what you're talking about. For instance, multiplying matrices, they felt that, and they said in their course evals, it doesn't have to be for grades. Could you provide some resources where we could practice these skills? And so they weren't necessarily asking for, I think, the delivery of the content to change, but they wanted those things to take home with them to work on those things, so they felt more confident than when they were in class.
Yeah, so my hope is that if they've learned how to play, and play involves going to the resources, and so then they would be able to go to the online resources, which are staggeringly rich. So I Googled arc length for this, and it's right there. It's beautifully laid out. Here's what it means, and right on online on these resources. So, but that's the hope. It's a great question.
Okay, please maybe take 1 minute. We are into lunch, so if you have comments, just please keep it short. Okay. Okay, well, I guess it's lunchtime now. So, of course, panelists will be available, happy to answer your questions during lunch. And we are back at 1.
We're supposed to get back at 1, but you know, we're a little bit behind the schedule. Let's start at 1:10.
Okay.
Is that
so so 10 after 1. Okay, thank you.
Thank you. Well, yeah.
Yes.
Okay. Okay, we're waiting for a couple of people coming back.
There's 2 online.
The 2 online, yeah. Good. Okay, welcome back. If you missed the talks and the panel discussion this morning, a recording of the entire session will be posted on Field's webpage. So you're welcome to check it out later. I think it will be available in about a week. Okay, we'll have additional panelists.
I didn't insert myself, you told me.
Yeah. All right, so for the afternoon session today, we invited our Canadian colleagues from Alberta and BC to discuss the undergraduate math curriculum, assessment approaches, and related issues. There are obvious challenges, conundrums, and dissatisfactions in the status quo. Let's talk about it, and hopefully we will be inspired by the discussion and inspired by each other to have better ideas about how to go forward. Now let me introduce, the slides. I'm supposed to run this. Okay. Let me introduce our panelists. Okay. So we have 4 panelists for the afternoon session. First, we have Vincent Butra. He's a professor in the Department of Mathematical and Statistical Sciences at the University of Alberta. His research focuses on new mathematical structures motivated by modern physics. He's passionate about teaching, and he is a recipient of the Rutherford Award for Excellence in Undergraduate Teaching, a premier teaching award at U of A. Vincent is joining us online today. Welcome, Vincent. Please say hi to us.
Hello, everyone. Can you hear me?
Yes, thank
Good.
you.
Happy to be here.
Good. No, you can be here. No, do. Stay with us. And next we have Folk. He's a professor in the math department at UBC and a winner of a number of teaching awards, including the Canadian Mathematical Society Excellence in Teaching, the Pacific Institute for the Mathematical Sciences Education Prize, and the Keelan Teaching Prize. Folk, welcome to join us in person today. We also have Wes Maciejewski. Maciejewski. Okay. He's a faculty member at Red Deer Polytechnic in his home province of Alberta. He has taught mathematics at UBC, the University of Auckland, and San Jose State University. in the States. He's actively involved in national discussions about undergrad math curriculum and teaching, and he maintains an active research program in mathematics education. Wes is also here with us today. Welcome, Wes. And lastly, we have Asia Matthews. She earned her PhD in mathematics from Queen's University with a research focus on undergrad mathematics education. At Quest University, he designed many seminar-style courses, including a foundational course in mathematical thinking and mathematics communication, and an interdisciplinary modeling course. A student at Quest rated Asia's course among the best in Quest history. Asia is joining us online today. Welcome, Asia.
Hi, everyone.
Hi. Okay, so let me start with Wes and Folk, since they're here. Why are you here with us today? How content are you with what we're doing day in and day out? Wes can go first.
Hello, can you hear me? Fine. Was this question one or leading up to?
This is a warm-up question.
A warm-up question, okay. Thanks for inviting me out. Well, I'm here because I was invited, of course, but also I'm not completely content with what I observe in math education at the post-secondary level. I think, and I'll talk more about this during the panel, I think what we're doing hasn't changed for a very long time, yet the world and our student body has, and we're kind of neglecting our practice if we don't start catching up.
So you're not
leave
completely
with very brief
content.
comments like that.
Yeah, Folk, anything to add?
Thanks for the invitation. Yeah, I mean, I'm here because of the invitation. I think it's always great to spend time with this community. In terms of contentment, I think I agree largely with what Wes has to say. I teach at a UBC, which is a large public university. And I think there's always a constant tension at these places between the public and the university part. The public part tends to push you in the direction of scaling up, but the university maybe implicitly tends to push us in the direction of scaling down. And I think balancing those things is a continuous task and a constant challenge.
Yeah, we will talk a little bit more about that. We bring Miro here because this question was actually from Miro, and you can also show your perspective on this question. How content are you?
Well, I mean, I can say I'm not content, but there was an interesting thing. We had a departmental meeting, and it was all just doom and gloom, like all going to hell. And there was a colleague who came from France, and he listened to us. And afterwards, he told me, "Well, what are you guys talking about?" He said, "Come to France, and you'll see how bad things are." Okay, so sometimes maybe we're overly critical, or we expect too much from things that actually maybe even cannot be improved, right? See, in mathematics, we always try to say something exists or doesn't exist, but in math education, there isn't anything like that. So there's no kind of maximum, there's no ideal to which we can all try to get to, right? So education is a completely different animal.
Thank you. So we will talk a little bit more of your discontent, but let me start with round one question. Now I'm going to invite Vincent and Asia to speak. So on curriculum issues, the current undergrad math curriculum is far from ideal. There must be something valuable, something interesting, something worth learning. So in your view, what is the gold in it, and what's the rubbish? Vincent, do you want to go first?
Okay, hello everyone. Well, first it's a pleasure to be here. I'm very excited to be here. So I think there are a lot of good things. I'm an optimist, so I think we do a lot of good things in general. However, I think we can do a lot better. I think my point of view is that the current curriculum is what I would call cognitive dissonance. Right? Cognitive dissonance in psychology is when you do something, but you don't really want to do it, but you still do it, and then you feel bad about it, and then you rationalize, and so on and so forth. So I think that's exactly what we do in undergraduate education in so many different ways. Like, for example, we say that we care about skills, like or virtues, whatever you want to call them, like logical thinking, problem solving, abstraction, all these things. Yet we teach content. We teach students how to take derivatives of complicated functions, and we expect these skills to be acquired as a byproduct. That's cognitive dissonance. We as mathematicians, we care about the process when we solve a problem much more than the answer. Yet we design our courses by focusing on the goals or the learning outcomes and not the process. That's cognitive dissonance. We say that we want to decrease the fear of math in society in general, yet we have the lowest GPAs in the university. We fail tons of students. We see our courses as gatekeepers. I mean, again, that's cognitive dissonance, and so on and so forth. I could keep going. For example, we say we attach a lot of importance to diversity, equity, yet we teach in a very hierarchical way with the white male guy in front of the class telling students what you do. I mean, that's, again, cognitive dissonance. So I think what we need to do is think about our curriculum and try to harmonize what we do with what we think is important. That's my point of view. So we'll talk more about that in this panel.
Thank you. You will try to harmonize. I like the word you're using. So Asia, do you want to talk about the gold or the rubbish?
Hi, I'm also happy to be here. I wish I was there in person. It's not how the cookie crumbled this time. Hi, Wes. So nice to see you. You're so far away. Old friend. I'll make a list. I'll make two lists. So I think that there is certainly some gold in what we do. And I think one of the things that we do well is we might be one of the only places where we talk a lot about abstraction. We do a lot of abstracting. We play around with abstract thoughts. I think that's good. We also are a place where we familiarize, undergraduate mathematics is where we familiarize people with many different systems that they might not see elsewhere. And we do focus a lot on logic and deductive reasoning. Maybe not as much in undergraduate as we do in graduate mathematics. But I think, as Vincent said, like that is we think we do, and ideally we do. But that's all I have for what we do well, or what's the gold. As far as the rubbish, it also sort of says, it's a lot of what Vincent said, which is, we do a lot of, and also what Wes said, like we haven't caught up to what the heck is going on right now. We are still teaching people how to compute things by hand when we don't need human computers anymore. We discourage learning by mistake by asking people to give right answers. People are so stuck on getting the right answer still that I think creates a lot of fear. And so that's one of the things that I think that we do terribly. And the last one is the one that's maybe the most important to me, which is that this occurred to me a few years ago while I was teaching, and it made me laugh for a little while. And I thought about it as like silly, that it's this subject that we have, mathematics, is so devoid of emotion, theoretically, and yet it brings up so much emotion in students. But really, that's the thing that we should be looking at directly, is our emotional relationship to what we're doing with our brains. The the mind-body connection.
Thanks, Asia. Miroslav, do you have anything to add or agree? So that was some thoughts from Asia and Vincent on curriculum. Now we have some questions about assessment piece for Wes and Folk. What changes in assessment approaches have you noticed since you were an undergrad student?
So I have three that I can think of. One more or less positive, one more or less negative, and one I think a bit of a wash. So the thing that I think is essentially all positive is the normalization of web work and other kind of online skills testing software. I think this provides a cheap and reliable way of asking students to practice that which is maybe not as important as it currently is, but still has a place in our curriculum. Something that is mainly negative, I think, is the wide availability of fully worked online solutions. So it was maybe I was on the margin of this change. I think students who came up before me at Queen's, which is where I did my undergrad, those many years ago, would remember kind of doing an assignment, and then after the assignment was handed in, someone like Peter would post some solutions behind glass on a bulletin board somewhere. So they would still get fully worked solutions. The solutions were good, but they came to them in the right order. Now, I think with 3 clicks, you can get fully worked solutions to almost anything online. The existence of those solutions is fine. It's neutral, but the availability of those solutions while you're doing your assignment is maybe not so good. And the third thing that I can think of that I think turns out to be a bit of a wash is a really cheap computational power. So I think on the one hand, this is very positive because it means that students can get right into some very sophisticated mathematics. On the other hand, I think if we're not careful about it, it deprives students of the ability to acquire a certain kind of back-of-the-envelope intuition, an at-a-glance understanding of things like functions that doesn't make them less good at mathematics, but it makes it's just something to be careful of, something to watch out for. So 3 things: web work, good; fully worked solutions, more or less bad; computational power, good and bad.
Thank you. On the same note?
Yeah, I've got some slides. Otherwise, I'm just going to forget what I was going to say.
There you go.
So here we are. It says what has changed in assessment in the last couple of decades. Just advance it one. Oh, I can do that.
Oh, it's
Okay.
not working.
No,
Oh,
it works fine. How do I go back? There we go. Okay, so here are two questions from 2 separate exams, courtesy of Peter. These are from Queen's University, so I want you to just take a brief look and tell me which one's older. Okay, so put your hand up in the direction of the one you think is older. Okay. Everybody has to vote right now. Which one's older? Okay. Utter confusion here at the Fields Institute. Hands flying in all sorts of directions. One of these appeared in 2004. The other one appeared in 2023. I forget which is which. They look the same. They look the same, really. But you know, this is despite there being great progress in research in undergraduate education and in math education in particular. Okay, we still are more or less doing the same thing, perhaps at a structural level. We see maybe some superficial changes, but fundamentally, I think things haven't changed. This one's just working. Yeah, oh, come back. Okay, I'll just mention something in a broader context, which is PISA. We saw these results show up last month, and accompanied with a lot of hot takes on it. you know, many of the media outlets are decrying our rapid decline on the PISA scores. And as you can see, people at the Globe and Mail paid attention in Stats 101 and have started their graph at 0 so that we have a more realistic view of the decline, the supposed decline. They didn't. Anyhow, we're trying to compare students that wrote this in 2002 to students that wrote it in 2022. And I would say this is apples and oranges. I've indicated on this graph where Google was founded. You know, those students that were writing in 2001 or 2002, cell phones weren't a thing. Google was just taking off. And now the students that write it in 2022, this is their lives. This is how they interact with the world. Don't think for a second we can compare these two groups. I think part of this decline is really because our students have changed while we are holding fast to a bygone era. And really what I'll talk about in all my responses here is really about values. What do we value as educators? What do we desire for our students, and who do we desire them to become? Okay? And so when we give them a question like this, climbing Mount Fuji on the PISA, which I would get wrong because I don't actually know how many days are in each month, which I don't think is a deficit in my mathematical ability. If we ask this, we should be also asking at the same time, how is this developing our students into the people we desire they become? Moreover, is what I'm doing actually relevant?
Thank you, Wes, for the other examples. Yeah, there are things that have changed, but there are things remain unchanged. We can talk about that the changes or the unchanged things a little bit more. I know we need to be critical about what has been done, the old ways, but I also don't think we need to wipe out everything we had before. Okay, let's find out. Now let's turn to round 2 question, which means our panelists gonna send you the core messages that they really want to convey today. So should I repeat the Stoic quote again? I have the same question from Nero. So the Stoic philosophy says that education is to teach young people to desire the right things. And so now the 4 panelists, you have your proposal of whatever assessment should look like, what the curriculum should look like, and what are the right things in your proposal. We want to start with Asia, Vincent, or yeah, okay. Asia and Vincent, you.
Hello, I'll start. I recently came across, well, recently, like in the last year, have been reading the, what is OECD, Organization for Economic Cooperation and Development, gazillion page report that they put out about like, what should we be doing with education, and why should we be doing it in our world? And the thing that keeps coming back to me in that, which I think they put really well, is responsible global citizenship. And that for me is why I teach. It's why I care about teaching people mathematics. And that does not mean to me teaching people how to apply mathematical techniques out in the world necessarily. It could include that, but it also means developing the ways of thinking that we value in mathematics and using the ability to think abstractly, the ability to communicate an idea carefully, how to argue what's going on in your head, which is always a mess, in a way that's clear enough that you can send it across to someone else and they can pick it up, so you can convince someone. Those types of things that I think we do, I have picked up, I think, a lot in mathematics, and I think that we value those things, are part of this, like what it means to me to be a responsible global citizen. And I think for me, that's what education is, and that's what mathematics education is for me. So in that report, they talk about competencies. And I know in Ontario, competencies is a word that shows up in curriculum a lot. And so for them, competencies include 4 things. And as I think about all of the things that are important to me in math education and valuable to me and what I think we should be doing, I can fit them all into these 4 things. It's actually quite amazing to me. So they are knowledge, skills, attitudes, and values. And certainly for a long time, and even now, math education, I think, focuses on knowledge. What Vincent and I are talking about in a paper that we're writing on looking at the undergraduate mathematics curriculum from an anarchist perspective is how to shift that focus from knowledge to the skills that we care about people developing in the undergraduate curriculum. And that includes things like certainly computation, but also really focusing on what it means to abstract, to think abstractly, to do things abstractly. What it means to care about mathematics in the world and how we care about human beings learning mathematics and how we engage with one another. And that's like equity and diversity and really thinking about dominance and power and all of that stuff. Communicating, all of these things are skills that we want people to learn. And for me, that's one of the most important things that most important changes that we make is to shift from a focus on knowledge to a more holistic perspective of knowledge and skills together. And then attitudes certainly are important, and that, like Sarah was talking about, is how well, and then there's values. So attitudes and values. And we want people to play, and we want people to walk into a math class and like be excited about doing stuff. And that those are changes that I think we need to make. And I think that we make them by getting away from this more rigid action of focusing on knowledge. Let me just look at my notes for a second. I have a couple more things. Okay, so I guess maybe just practically, how do I think we can do that sort of thing? There are a few ways. And as a pure mathematician, I die a little bit inside every time I say this, but I do think that modeling is a really valuable way to get into, an easy way to get into all of these things. And of course, it has to be authentic. It needs to be authentic, like trying to quantitatively model authentic, complicated systems. Is one way that I think that we can do that. And then in the classroom, the human to human interaction is going to need to change, I think, from what it has been a lot. I think we need to connect with human beings a little bit more than we have. I will leave it at that for now.
Thanks, Asia. I think Vincent could speak more about the anarchist approach. You guys work together?
Hi, yes, so you're asking what is the right thing about our proposal. So the first thing I would say is that I'm not proposing anything about the curriculum, and I hope no one does, because I don't think that's the way to go. But rather, I would like to propose a way of thinking, each of us, about how we can change the curriculum. And as Asia said, I think, well, as I said before, I think the big problem with our curriculum is that it's cognitive dissonant. And there is an approach in political philosophy that is exactly about this, which is called anarchism. And anarchism means lots of things in society. So what I mean here is kind of modern anarchism. So it's basically, I would say, focuses around 3 points. One is that it's a focus on process. So every single decision you make, you should do it to be consistent with your values, with what you really want to do, which is the response to cognitive dissonance. Second is a challenge to hierarchies. So that doesn't mean we're all equal, we're all different, but the way we organize as a society or as a curriculum should reduce hierarchies instead of increasing them like it does. So we should focus on a system that reduces hierarchies. And the second thing would be, the third thing, sorry, would be a focus on diversity and open-endedness, which is exactly what mathematics is about. There's many ways of solving problems, and mathematics is about asking questions, not fixing goals, but it's very open-ended. So anarchism is a perfect framework to think about the curriculum, I think, because mathematics in itself is kind of anarchist. So that's what I would like to think when we think about the curriculum. But it's not so much like we're going to propose an anarchist curriculum. That would make no sense, because that would assume that I know better than you guys, which is exactly the point. That should not be the case. So the idea here is more to propose some ideas, some food for thought, say, about how we can change the curriculum. And just some quick ideas that one of them Asia already mentioned would be to maybe focus our courses on skills instead of content. So have a course like Abstraction 101, Problem Solving 101, or things like that, where we really are consistent with our values. So if what we care about is the mathematical reasoning, virtues, or skills, let's teach those. Let's not pretend that the students will acquire them by chance. That's one thing. Another thing is the whole grading process, which is very, very hierarchical. So what about we go in the ungrading direction, right? It's a trend in education where, for example, I'm trying that right now in my course. I'm teaching Calc 4, which is not a small course. I have 150 students, and there's no marks in the course. So we will assign the grades collectively at the end of the course, like me and the students, like as a one-on-one. So I have a whole process that I thought about, and I'm trying. Now I can't say how it's going to go because it's only 3 weeks in the semester. But so far, the students have been like super involved in the course. Like it's been amazing. So I don't know what's going to happen, but like trying things like that to reduce hierarchies is another thing I'd like to think about. Another way also is about designing courses. So as I said before, the general idea in math education or education is to always design courses or programs based on outcomes. But if we care about is the process, why not design the courses based on process, not outcomes? So why don't we design courses based on questions? We ask a few questions, and that is the course. So we don't fix the outcome. It's an open-ended process, but we fix the starting point. So it doesn't mean anarchism doesn't mean chaos and there's no structure. There is structure, but it's focusing on the process and not the outcomes. So anyway, these are just a few ideas, but I think if we frame everything in this from this point of view, the curriculum could look very, very different from what we currently have.
Thanks for introducing the new framework or new ideas. With an example, Wes has been nodding. Do you want to react to what Vincent's talking about? I just agree. And
I agree.
Anything you guys want to comment on before we move to the question for Phil and Wes? Yeah.
See, on top of everything that was said, we also have to face questions which actually some people might think are uncomfortable. And one of them is the following. Who is actually sitting in our math classes? Why are they there? And in my view, so I'm not the worst possible teacher in the world. I'm teaching a course that I'm very excited about, and students feel that. From the first week of classes, half of my students aren't there. And my message to them is just get the hell out of my university. But see, we don't talk about that. We assume that all students who are there are willing to learn, willing to play. Some of them are, and we love them, right? But we always have this schizophrenic thing, there's this idealistic thing we think about and we love about teaching and about math, and then there's a reality that hits us hard. I talked recently to a high school teacher. They bring kids to visit, and kids do something, and I talk to teachers, and he told me, for me, the most important problem is to finish the material, because half of the time I spend in classroom, I have to control my students who are special students. He said, one student, I'll let him sleep because he's violent if he's not sleeping. That's the reality, right? And we rarely actually talk about these things. right? So this is all great, right? By the way, Vincent, I don't want an ungraded engineer to build a bridge, right? They can build a bridge in their backyard if they want to, but not one I'm going to use. Okay, thank you.
Thanks, Miro. Wes and Phil, you can talk about the core ideas or core message you want to convey, or you want to respond
We
to
have
that.
a different question, the two of us. We're supposed to react to assessment.
No, we're on round 2, so you need to tell. Still on, yes,
okay.
still on Stoic.
Yeah, I'm happy to address that. I will say that I think there is some sort of happy space somewhere between the radical idealism of Vincent, who, by the way, presents the most palatable, lovely vision of anarchism that I mean, if anyone could convince me to take a pop at Franz Ferdinand, it's Vincent. But so I think there is a happy space somewhere between and I say this with the utmost admiration, the kind of radical idealism of Vincent and maybe the radical realism of Miro.
I'm both.
And maybe Miro occupies that space. I did, though, if it's okay with you, just wanted to take a moment to respond to the question that you asked about Stoic philosophy.
Yeah.
So I wrote down the 4 things this morning, just so I wouldn't forget them. So they're justice, courage, wisdom, and moderation. So I think implicit in this question, how do we desire students to, or how do we teach students to desire the right thing, is the question of how we teach students not to desire the wrong things. So by the light of the Stoics, that would be distress and fear. Those are the opposites of justice and courage. And then their positive bad things would be delight and lust. I'm just saying what they wrote, right? So this stems from the kind of general Stoic principle that a philosopher should understand their locus of control and be essentially kind of immune to the vagaries of chance. So I'm not sure people are familiar with our proposals. So if I can just sketch it out in 20 seconds, it's a modest proposal, and I feel slightly sheepish about the modesty of it. So if my colleagues online will kind of forgive me for the bureaucracy of this proposal. It's essentially to say that about half of the points on a final exam should be devoted to, let's say, one question that is considered by the students essentially to be undoable, or at least uncompletable within the time frame of the exam. So I'm happy to kind of dilate on that in the next question. But with respect to the Stoic question, I want to ask, so what do you think Stoics would think of how our students currently write exams? Right? So not only are they not immune to chance, but they're primed to think of themselves as vulnerable to chance. That's kind of like victims in a horror movie. They don't know what's going to happen, but they know it's going to be awful. So my proposal is essentially not to change the thing that we're asking them, but to change the expectations of the students, to normalize this. So not to be victims in a horror movie, but to be people who are preparing for something quite difficult. So someone who says, I know what's coming, and I know it's going to be bloody, but I know it's coming. So good questions would still seem to come out of nowhere, but they would seem that way to everyone. So they would not be arbitrary. They wouldn't privilege some students who got lucky over other students who didn't get lucky. And there would be no expectation that anyone would finish them. And so if this thing, a big part of this trick is priming students for this sort of thing beforehand. But if you prime them for this beforehand, then I think that can, in fact, release them from a bit of fear. You can get good marks. You can get very good marks on this question, even though you will not be able to finish it. So I think in summary, math already contains a lot of the right things. I think the Stoics knew this, but our students perceive them or they encounter them as the wrong things. With respect to some of the presentations that we heard this morning, I think this has to do with being clear about the didactic contract in universities. I think it has to do with removing from them this idea that, I think this is in the second talk, in Igor's talk, that mathematics is territory for the knowers. But it shouldn't be. At least for 50% of the exam, no one should be a natural occupant of the territory of the knowers. And lastly, with respect, I think it was Sarah's comment in the panel, where she said some students are scared to dig into it because of their non-expertise. Again, for 50% of the exam, I think everyone should feel non-expertise. And in that sense, it's both stoic and empowering.
So that's folks' proposal. We'll get more details in that for round 3. And Wes, you wanna? Yep. This is what I'm doing. No, not this one. This one?
No, it's
this one. Okay.
There we go.
Next.
Yeah.
No.
Okay, so I was asked to comment on assessment and what I would propose to change there. So next slide. Oh, great. Of course, those who know me know that I've been talking about this for a little while now, that I'm convinced we really I'm convinced that we really ought to be allowing our students access to all tools and resources at all times, including during an assessment. Okay? As a practicing mathematician, that's how I live my life anyways. If someone asks me a question, I might have forgotten a certain form of a partial differential equation or something like this, I'm going to go to Wikipedia and I'm going to look it up, and I'm not going to feel shame about that. I think we ought to be normalizing that and allow our students to have those tools at all times. Okay. Next. Of course, not everyone agrees with me on this. Some might view this as counter to having our students learn. And I think that's a worthwhile comment to really engage with. I think we ought to isolate that and focus on what do we mean about caring about our students learn, okay? At this point, I think so many of the participants throughout this day have mentioned something, either implicitly or explicitly, and this is what I want to highlight. It's all about values, okay? When we say, I care about my students actually learning, that is a value-laden statement, okay? What exactly do we mean by that? So next. This is how if I were to create a schematic of what we're doing in education, it's this, okay? Learning outcomes get a lot of attention. Learning activities get a lot of attention. Assessment does. They all do in isolation get a lot of attention. We've seen great work in the last 30, 40 years on like constructive alignment, making sure our assessments are actually assessing what we had our students, we sought our students to develop and things like this. We've developed a lot of great classroom activities and ways of engaging students. But the one thing that's kind of lurking that we're not really grasping here are the values that we bring as educators, okay? Values dictate everything we do. They dictate what we want our students to learn, dictates what type of activities we engage in with our students. It dictates how we assess, okay? So we ought to take that out of the background and move it to the foreground and discuss those values. Okay. Okay, here. So let's talk about values and why do I propose to have students cheat? You know, this isn't a novelty. I'm not saying we should do this because ChatGPT is a trendy thing to do. I think it's actually very liberating for us and our practices to allow students to have these tools at their disposal. Okay? Asia mentioned this, and I think we all kind of acknowledge it. Computers are much better at solving routine problems than anyone here. Okay? The time that we need human computers, that time is gone. Okay? Katherine Johnson and the calculators in the basement launching satellites. That's a bygone era. We do not need to be doing that. And in fact, if we emphasize that on our students, we're making them redundant. Okay? So the focus ought to be on the things that the computers can't do. Computers cannot reason. ChatGPT is a fancy autocomplete. It doesn't know. It can't reason. That ought to be the focus for our students and what we promote with our students. And we can do this by allowing them to access all tools at all times. Okay? The true strength to this is that we as instructors are forced to ask better questions. We no longer have to ask, compute this, graph this. we can, if you want to think of it in these terms, we can start climbing up Bloom's taxonomy. No longer do our students need to memorize things, understanding, sure, but now we can start asking, evaluate, and create type questions and open up access to those things that we didn't have before.
I want to know if...
Can I just ask a point of information on,
yeah,
on this?
Because the four of you should interact also. Yeah.
Okay, let me interact with Wes. So by, does cheating allow collaboration between students or collaboration with people outside the exam room?
Do you want it to?
I don't even know if I want to do this.
Okay.
But
So
in your conception.
So in my practice, I acknowledge the influence of institutions. What we do doesn't exist in a vacuum, right? And so I'm aware of this. And so I don't take the exams as far as I would like them to, because I am also acknowledging the role of the institution. That's a long-winded way of saying I don't allow collaboration on my exams, but I'm certainly open to the possibility of it, okay? I think the only thing that would hold me back is my own inability to imagine what that looks like. Kind of like a boundary of my creativity that I haven't yet pushed out, okay? I certainly think there's a space for that, because when you're working in any environment in the world now, it is all about collaboration. So maybe we should be looking at how do we assess in a collaborative environment.
And Vincent and Asia, do you have questions or comments on Wes and Folks' proposals? Yeah, Vincent, go ahead.
I just want to say I completely agree with Wes. I wouldn't call it cheat. I would call it just, let students use tools. And that's what I do in my exams. It's a fully open computer and open everything, except that that answers maybe folks' questions. So usually, at least for me, I distinguish between collaborative work, like where they're allowed to collaborate and where they're not. And if they're not, then I do draw a line, for example, with Chegg or ChatGPT is now a bit, but Chegg is basically asking someone else to do the work for you. So I don't think if it's going to be individual, then that's not quite allowed. But anyway, all I wanted to say is I think this also fits very well within the kind of anarchist framework of thinking how assessment can be consistent with your values. And if this is what we do as mathematicians, we should also have students do the same thing and be consistent with what we think is the way we do mathematics.
Yeah, Wes, you want to respond to that? Or and Miro, you have questions, or Folk?
Yeah, so I don't think we're guilty of this yet, but I think there's a little danger of conflating assessing students' creativity and allowing them these tools. I can imagine a world where none of these things are allowed. In fact, I can imagine a world that's even more restrictive, where the assessments are even more restrictive than what we impose on students now, where you could still ask creative questions. Right? I think it doesn't. I think having a really constrained environment doesn't mean we have to ask banal computation questions. But I think that's where it's led, which is an error. But it seems to me that there's a second value at play here, which is that we want our students' experience on an assessment to reflect their experience not in an assessment, which I think is worthwhile in itself, but a second category of value. Is that fair?
Yeah, and I agree with you entirely that you can still have creativity and constraint, right? And you hear that in music, and you see it in athletic performances when you see a sport that has a lot of rules, like fencing. I'm a big fan of fencing. Lots of rules, very strict, lots of culture that comes along with it. But when you watch an actual good fencing performance, it's creative, right? And it's the same with music. Music is actually fairly strict, but you wouldn't call it not creative. And we can do that within constraints. And I think the issue is, like you said, that we don't do that often because we're led into that kind of more unstable equilibrium of reverting to asking questions that are easy to create, okay, right? And that makes total sense. We have very practical constraints that force us to do this. And I think part of what's baked into my proposal here is that we are at that unstable equilibrium and we need some sort of perturbation to get out of it. And for me, the answer is, look at, I liberate myself as an instructor when my students have more to work with.
Mm-hmm. We'll talk a little bit more about the constraint for the third round because Wes going to focus on that particular perspective. Miro, do you want to comment on? Yep. Okay, so let's go for round 3. These are specific questions for the three groups. Maybe we'll start with Asia and Vincent first. So here's a question. I quote Bob Dylan. Freedom is just around the corner. This is one of the lyrics of his song. Freedom is just around the corner for you, but with truth so far off, what good would it do? Freedom matters, truth matters more. This is the very reason we built the university in the first place. So the question is, when you design a math curriculum, how do you reconcile the tension between what you want to teach and the choice or freedom you would like your students to have? Asia, you want to go first?
No, I don't want to go first. Vincent wants to go first.
Oh yeah, Vincent.
Thank you for asking.
That's okay.
Okay. Yeah, well, it's a very interesting question. First, I want to say that, as you say, the focus is on truth, and in fact, that's one of the beauty of mathematics. Is that the focus is on truth, and that's why I think of mathematics in many ways an anarchist endeavor in its own, is because you don't appeal to authority in mathematics, at least idealistically, right? Whether something is correct or not does not depend on who said it. It's just a truth. So this in itself is very different from most things in society, where the authority of the speaker is very important. Not so much in mathematics. Again, that's ideally. I know that's not really how things are happening in the mathematics community, but ideally that's the idea. But I think what you're asking though brings a very important, I think, distinction to make, because I think when we talk about things like anarchism, then there's what comes to mind is things like freedom, and then people talk about the freedom convoy, or things like, where everyone's opinion is just as good as everyone else. And that's not the point at all. I mean, I would completely disagree with that. I think there is certainly a difference in knowledge, for example, between the instructor and the students. I mean, I certainly know more about the topic I teach than the students in my class, just by experience. I've worked with it for a long time. And I think that is important and should be respected. However, that doesn't mean that I should have power over the student. That doesn't give me the right to impose my power. It just means that I have more knowledge, which is fine. So I think when you think of it in this way, and you think of yourself as an instructor as a guide, right? The students will learn the material, that's the goal. And you're just there as a guide. And then your knowledge, of course, is important to be able to guide people. Just like, again, I like to think of the idea of a doctor, a physician, right? If you go to see a physician and they diagnose you with something, they will guide you. They will tell you what course of action you should take. They can't force it on you. You could say, no, I don't want to. And then you could leave. And in fact, some people do, but most people will not, because we respect the knowledge of the physician. But it's not a power relationship. The doctor doesn't have, unless of course, you can't make a rational decision or something. But the doctor usually doesn't have power over you. So I think it should be the same thing here. The focus is on the truth itself. The freedom shouldn't go, students, there is freedom in there, but there's also respect of the different knowledge. And I think I'm not sure I'm making sense, but I think it's making sense in my head. But I think that's a very, very important distinction to make.
What I'm getting at is you're saying freedom and truth, they don't have to contradict, or structure and truth, they don't have to contradict. And there's a way to ease the tension between the two.
Yes, exactly. And there's a way to respect differences in knowledge and without necessarily falling into a hierarchical structure, which is kind of what I think is important too.
And Asia, now do you want to add anything?
I certainly do. I guess when I think about the different words, freedom and truth, in terms of what we do in mathematics, truth is certainly one of the things that I love about what we do in mathematics, and that is, and the idea, there's a quote from a Calvin Clausen book. He says that something like proof is the democratization of knowledge. So we write, it doesn't matter who wrote it, the idea of an argument, arguing truth, is democratic. We can all access that in some sense, and it doesn't matter. This is the same idea that Vincent was just saying. It doesn't matter who's saying it. It's not the authority. It's the ideas within the argument, and that there is certainly a tension, and it's one of my favorite places to play in the classroom, is to talk about, certainly there is truth, but you have complete freedom in how you want to argue that truth. And that there is a creativity that I think we fail a lot of times to draw out in our students. And that is where I see that tension, and both things living simultaneously, is we have truth, but we have the opportunity to encourage our students to be creative in how they argue, in how they represent things that are going on in their heads, how they draw figures, how they create notation, how they try to conceptualize, create a concept that's palatable to someone else. But furthermore, I would go further. The creative opportunity, another creative opportunity we have in the mathematics classroom, is to help students learn how to ask new questions, how to pose new problems. This is how mathematics moves forward. And we do so little of that. And I would love to see allowing students the freedom and giving them some guidance in how to do that, and actually spending time there, instead of focusing more on the technique. I'd like to, which is valuable, and that's true. There's truth in there, but I think the creativity, which is actually sort of historical, like how do truths develop? It's because we ask questions and then we notice patterns. And if we spend more time there, that's how I see us reconciling these two things.
A related question for the two of you about the freedom aspect. Under what circumstances you would, if any, would you co-design or co-create a course with your students? Because I didn't live
I'm
in
so
the
ready to
where...
answer this question.
Sorry?
I'm so ready to answer this question.
You are, okay, you are. Because my concern is I didn't live in the age where my professor asked me to do that. But very likely my response is, I'm a high school graduate. I know nothing. And I don't think I could contribute much. So how do you respond to that? Okay, you too, go ahead.
Yes, yeah, any circumstance, I'll try anything. So if I have a very large class, I will happily try to figure out a way to create a class with them that's valuable to all of us. If I have a small class, I can see it being easier, and I also would do that anytime I would do that. But I also would say that I do that. That's part of what I think for my values, being a good educator is engaging with the students, not just pushing my own agenda, but listening to them and changing what I want to do in the first place, maybe throwing it all out if I can do something more valuable for them. So I certainly can see any situation I could do this in.
And how do you respond to me? I just don't, I can't contribute. I know very little about what I'm going to do in undergrad because I didn't even do well in high school.
So maybe again, because that's what I was going to answer. I think that the problem here is the way we design classes. Because if we design a course based on the endpoint, then your argument is valid. You're coming in the course. Of course, it's hard for a student to say, well, here's the endpoints that we should reach because they don't know the material. So how would they know what the endpoint should be? But if you think of the course as a set of questions, then you can design the course with students because they come in, they have questions. So let's figure the questions together. And of course, I have more knowledge, so I know where that's going to guide us. I can kind of help formulate the questions with the students in a way that will make us move in the direction that the course kind of roughly should go. But then we can work together, right? So if you focus on the process and not the outcome, then you can work with students to design the course, I think.
Do we have comments from the stage? Coach?
Yeah, okay. I have a question, but only because I'm being prompted to, or I could just suppress the question.
No, don't worry about it.
Okay, so I'm asking this question only because I am kind of seriously considering and wrestling with some of the ideas that, some of the very provocative ideas that you're bringing up, and I want to provoke the question from the left. So, how would you respond to someone who says, like, so to get a student to come into your class and to invite them to create the class with you in a non-hierarchical way actually privileges the student who grew up in their kind of East Coast Quaker hippie school, and they're kind of well versed in like whatever Kimberly Crenshaw, and they're happy to go there, versus the students who are going to a public university who belong to a community where not only do hierarchies matter, but they're both not bad, and they're a source of traditional strength for those students. And you're kind of, and by doing this, you're kind of torquing them toward the East Coast hippie school. Okay, is that how would you respond to that?
I mean, I don't know. Maybe Asia could. I mean, I don't think it's hippie in any way, but I know what you mean. But I don't think. I think my experience is that students of all, in my experience, like trying to do some of these ideas is not like I'm changing all the courses at the University of Alberta, because it's a big research university with large classes. I mean, we can't be completely radical, but I'm trying to implement some of these ideas. And my experience so far is always that students, the ones that you are the least likely to think they would be, interested in this, are super motivated in the sense that they feel, oh, now they can say something, and they've been raised in a very hierarchical environment and all that, and now they feel like a little liberated because they feel involved in the course in a different way than all of the other courses. Now, this is not to say every single student probably would like it, but that's also the case right now. I mean, half of our students are bored and don't care about the course. So I don't think we should pretend that this is going to be perfect. I mean, that's not the idea, right? But I'm not sure that answers your question, but maybe Aisha can say something.
I will say that this is exactly my experience as well. Having taught at Quest University, where I had many different types of people in my class types, and abilities and backgrounds. And I certainly had students coming from Montessori and Waldorf schools out in the East. And then I had students who had very traditional backgrounds and were very reluctant, scared to take part in my class. But my experience was pulling almost all of them into that. And just as Vincent said, the ones that I didn't expect to be ready for that were so excited to try something new. And if that's not what we're doing in education, and if we're not trying to get people to try new things, what are we doing?
Fair enough. Are you satisfied, folks? Sort of.
I'm happy to move.
Okay, let's move on to the questions for Wes and folks. Who wants to go first? Wes, you want to go first? Yep. So the question for Wes, there are two questions. If you could make one change at the institutional level to eliminate one constraint, we talked about constraints earlier, from the equation, what would you change? If you could make one change at the departmental level to eliminate another constraint, what would you do?
Okay, changes. What change would I make? Well, I'm not sure I would impose a change, because if anything changes, I want it to be sustainable. Okay, so I think really where the change has to come from, it has to come from us as individuals. It has to come from within us, each individually, because then we're invested in it. And then whatever change occurs, that's going to be sustainable. Okay, so I have a bit of a litmus test here for your own practices. Are you completely comfortable and confident in what you're doing at all times as an instructor? If you answer yes to that, I'm sorry to inform you, but you've reached your expiry date. You should step aside. Okay, you should be taking risks with your instruction. Okay, you should be experimenting with things. You should be doing things new. Okay, that sustainable change is only going to occur when we get comfortable with being uncomfortable. Okay, so I said I wouldn't impose a change, but perhaps I might. Okay, maybe I'll run for department chair and I'll make this change. It won't impose anything on how we change. I won't say explicitly how you have to change your education. But what I will insist upon is that every instructor has to state their values. Okay? Just whatever it happens to be in your assignments, in your exams, the start of the course, I value this. And that's all the change I would be. I would mandate everyone stating their values. Okay? Now I think this isn't opening the door to sustainable systemic change. Okay? Because this is the first step in critically examining our practices. Because as soon as we understand our values, then we understand our actions. We understand why we're assessing in a certain way. We understand why we're giving a certain curriculum and the activities to support that curriculum. Okay? So once we state that, we can critically reflect. And then the next step is to engage in that process of a constructive alignment and make sure that what we're offering is actually speaking towards our values. So I'll give you some examples here. This first one comes from our friend Anna Stoke in our November FinSIC meeting. Okay, so this is, she insists upon this worked example fading. So here I think she's trying to get her students to learn how to use the intermediate value theorem or something like that. So she gives a completely worked out example. She provides that to the students, and then a partially worked out example that the students have to complete, and then even less of a worked out example that the students have to complete. And then she trusts her students at the end there to produce their own solution that's supposed to look at like the original one. Okay, so it's this process of fading. Okay, so an instructor employing this might state as their values, I'm giving you this task because I value your ability to parrot back to me exactly what I showed you to do. Okay? And I'll contrast it with this example here. Not saying this is a superior example or something, it's just strictly different. Okay, so find a function which corresponds to the following graph. Clearly show how you got your function and how it relates to the graph. Okay, so an instructor using this might say, I am giving you this task because I value your ability to independently solve problems you've never seen before, judiciously drawing on all the resources at your disposal. So now it's your turn. You try articulating your values. Who do you desire your students to become? And then you examine your practices. Is what I'm doing developing the students into who I desire them to be? Okay? Systemic change begins in your classroom, in your activities, and also on your exams.
Thank you, Wes. I heard applause from the audience.
I did not applaud. I don't. You don't have to.
And I think we can interact.
Oh, you do?
Yeah.
No, you have to.
And let's see if Asia and Vincent has comment on Wes' proposal. Nope, we're good. I'll agree with you.
Three thumbs up.
Yep. Oh, there's one more. So, okay, last set of questions is for Folk. So he proposed this new way of calculating or collecting students' marks and what could be done for a final exam. So here's the questions. You talk about large portion. How large is large? That's one question. And you talk about unfamiliar questions and unfeasibly to be completed. These are subjective and learner-dependent terms. Do you have an example to illustrate what you mean by such a problem? And the third question, so suppose there are two familiar questions. You talk about one or two unfamiliar questions to be included in the final exam, along with other questions. How would you assign marks to the unfamiliar and the ordinary? And how are the final marks are finally collected? So there's 3 questions embedded.
Yeah, okay, so let me answer briefly, because I think the interaction is really rich. And also because I think my proposal, compared to what else is being proposed, is so basic. Okay, so let me answer briefly. I think I'm going to use the Blackboard for the people in the room, but it won't be all that important for people who are online. So this is all work in progress. The numbers I'm essentially pulling out of the air, but as a first approximation, I think they're okay. So I was proposing that about half the exam be on kind of the comfortable technical stuff that students carry from their high school didactic contract. All or nothing, with maybe a grace point for typos. And the remaining exam be 1 or 2 questions. Let me just say one question. So the task of the exam in this sense is to gather from 1 hour or 2 hours a good prediction of how students are going to do on an actual, authentic, real-life 40-hour task. One way to do that is to release them from the constraint of having no tools. I think another way to do that is to just ask them the question that you would ask them if they had 40 hours and then see where they go with it. So it should be unfamiliar. It should seem unfamiliar to the student. And it should seem undoable to the student. So an example is in a differential calculus course. I'm pulling this example from an assignment that I gave. But in retrospect, it shouldn't have been an assignment. It should have been one of these kind of bonkers exam questions that I'm talking about. So it's a differential calculus course, and then imagine on the exam you ask them for the first time about a system of coupled linear differential equations. This would be worth 50% of the exam, and it'd be in kind of 3 categories, what they did. The first category would be stuff that is more or less standard, and you would give them hints. The second category, so that's worth about 10% of the 50%. The second category, worth about 20% of the 50%, would be stuff that's non-standard, but you give them hints. And the last category would be stuff that is non-standard and you give them no hints. So just to pin this to something concrete, like okay, so imagine that you, again, for the first time, so students have not encountered this before. If they encounter it before, it kind of deflates it of its purpose. But if you give them on the exam something like this coupled system of differential equations. Okay. And then so in category 1, stuff that they've seen before, kind of, you give them something that's not this. And you say, like, you can couple these differential equations and you can like graph trajectories. And so over time, you can have a trajectory that, I don't know, looks like this, right? And then you ask them some questions about this. So at this point here, say, I don't know, if you've got like deer and fish or something, what is happening to the deer, what is happening to the fish? So here you're just reading a graph. That's category 1. Category 1 is read this. Category 2, so that's category 1. Category 2 is like you say something about, you ask students to tell you something about null clients. You describe what they are, and you say, given that system of differential equations, tell me something about where x is not changing, tell me something about where y is not changing. You don't say that, right? Tell me something about, but you put a lot of thought into it, and they tell you something good. That's category 2. And the category 3 is you tell them just enough that they have all the tools essentially to calculate an eigenvector. Well, they don't know it's called an eigenvector, but you can describe what an eigenvector is without using the word eigen or vector. And they do some work with that. Now, the priming here I think is super important because, right, so in a traditional exam, you might get a shrunken version of this question on the last question, and this is the question that 90% of the students don't do because they know it's a special question. Right? This is the question for the keeners. Now, the idea is that this is a question for everyone. So everyone has got to try it, but no one is expected to complete it. In fact, you can get 80% by getting nowhere on part 3. Okay, so in rough terms, that's the proposal. I throw myself onto your mercy.
Thank you, Folk, with the example. We do have questions from the audience for Wes and Folk, probably for Asia and Vincent too. We have 5 minutes or so to take some questions. Please, Paul, read out.
Sure. For the benefit of the folks in the room, well, the first question came in. With so many faculty having so many different values, how do we standardize what students learn, or how do we have an idea of what students from different institutions or even different courses at the same university know and their approaches to mathematics?
So did Asia respond to that a little bit?
Asia did,
yeah.
Suppose we first start with asking if having a standard curriculum is one of our values.
And Wes, go ahead, yeah.
Yeah, maybe we should standardize our student body as well. Let's just do away with diversity entirely. That's not a serious recommendation. Don't quote me on that and let it appear somewhere. No, okay, no, but it's, students, all humans need to experience and engage with a diversity of ideas, and I think it's ridiculous that we try to silence our individuality as instructors and as students, with the aim of standardization. I think we need to have less standardization.
Folks, do you have anything to say to that?
I think I'm okay with less standardization. I don't think anyone is proposing no standardization, right? But I think it's important that a student from the University of Alberta, if they go in their 3rd year to the University of British Columbia, that we at the University of British Columbia know what courses they should be taking. I think it's important if someone applies to grad school that they have a corpus of knowledge. But in broad strokes,
we still work in institutions.
Yeah.
Yeah, I was going.
Yeah, Vincent, go ahead.
Yeah, because maybe I've sounded like the most radical of the four. And actually, in that case, I think, I mean, it's easy to take the point of view that West and Asia was taking, that, diversity. But I think, we also, I agree with Folk. I mean, we need to have some sort of way of distinguishing or knowing what the students have gone through. But I do think it can be done in a different way. I don't think standardization is the only way. I mean, we could have, if it was more of an open-ended process, we could still have at the end, and in fact, some liberal arts college in the US do that. So have some sort of transcript, whatever, that explains what the students learn. And in fact, the student could participate in writing this as well, and something like that. So there's other ways of finding, answering the question without having to standardize all the courses.
Yeah, thank you. We're gonna take, there are two more questions? One more, okay, go ahead, good.
This was from Pam earlier. How do you respond to things like when the Premier of Ontario says in math, let's stick with math, other social issues, let's talk about it. There's no doubt, but let's not talk about it in math. Talk about it in other courses that the schools offer. So stick to the math.
Stick to the math. Agree or disagree?
Sure, let's stick to the math. I mean, it's a ridiculous suggestion. You get your degree in psychology and then you get a job in Cisco systems, and someone says, "Oh, I need you to do this." You're like, "I got to stick to the psychology." It's stupid, right?
Good point.
I would say that it's certainly contextual. Like, what can't we have both of those things? I don't necessarily think that. I certainly don't think that we should just stick to whatever the math is, because I actually don't think that he understands what I understand when we say the word math. So I don't know how we even, like, we would have to sit down and chat about that. So what does he mean about stick to the math? Because for me, that's an entirely different question, and the math includes social stuff. So does he mean stick to computation? I'm not certain what he's.
Folk, you want to add something?
Oh, okay, I do. I feel like I need to. I really should have prefaced this by just saying, though it may not seem it, I'm temperamentally combative. So I want to try and defend the statement. If I take it in its the best possible light, you can kind of see, if you turn your head sideways and squint, a sort of like a proto-populist reaction to like people at universities sometimes unwisely straying from our lane. And I think there's something to that. We were talking a little bit at the break about, very briefly, about how the mission of universities often historically swings between kind of preparing what we take as to be like citizens of the world and teaching students stuff, right? So on the one hand, you're preparing people to live in the world. That's one end of the pendulum, and on the other end of the pendulum, you just think that the Beowulf or the poetry of Sappho or whatever is just worth learning in it and of itself, not because of how it redounds on our society, but just in and of itself. And I think it is important to have that corrective every once in a while, just to teach. It's important to teach stuff as well.
Mm-hmm. Okay, I think.
Sorry, I was flippant in my comment. I'm actually okay with being flippant occasionally, but to expand on that, it's whose math are you talking about? And should we in English class only work on vocabulary and sentence construction? Well, no, you still have to read something. In math, you still have to work on problems. Okay, so whose problems are you working on? Right. So I'll let my flippant comment stand because it was just as uninformed as the Premier of Ontario's.
I think it's a good note to end on. I do have to end the session because we Yeah, it's like we stayed here more than half an hour as we're supposed to, but thank you again for our panelists online and in person. Thank you for coming today. It was a great session. I completely enjoyed it. We would like to have your feedback. You know, if you want to tell us few things that we could have done better, and you can reach out to the panelists, and our discussion will continue on in a pub. You're welcome to join us. Okay, thank you, everybody. Thank you. Thank you, Vincent and Asia.
Thank you.